Good morning, evening, afternoon to everyone out there. Welcome to the Asia Pacific segment of JDConf. Before we get started, I just want to take a moment and just recap the Americas segment, which already took place. And you can see recordings of that over at jdconf.com soon. There's also some on-demand sessions over there as well. My name is Brian Benz. I'm an AI advocate at Microsoft, and I'll be your host for today. For the previous session of the Americas, we had Bruno Borges as the host, and we delivered sessions covering agentic development, modernization, security, and AI native Java. We began with a keynote with Rod Johnson and Bruno Borges. We talked about the agentic future. Please check that out. That was a pretty awesome one. Then we had Brian Sam Bodden presenting secrets of agentic memory management, talking about how you can actually design memory-aware agents. And then Ed Burns delivered Modernizing a Java App with Node front end. It was covering GitHub Copilot, showing how GitHub Copilot app modernization can help upgrade the front end and back end systems of a real enterprise app. I think we use the Eclipse cargo tracker for that. And then Mary Grigleski spoke on building scalable multi-agentic systems in Java. It covered Kafka, Pulsar, Spring Messaging, and MCP. Very cool session as well. Daniel O from Red Hat presented Cloud Native to AI Native, talking about Quarkus, MCP, and Azure OpenAI. Basler Rahman gave a session on building LLMs apps in Java with LangChain4j and showing how Java developers can add LLM-powered capabilities into their apps. Sam Grover had a session on intelligent Java tooling. And Anthony Dahan had closed the session lineup with From Vulnerability to Victory, covering CVEs, why you want to know about them, and how Java developers can fit into the whole CVE infrastructure. So now we're going to actually move on. So once again, check those out on jdconf.com. They'll be up soon as recordings. But we're going to our live segment for Asia Pacific, and welcome, folks. So Josh is going to be opening the session. I'll talk about his session in a second when I introduce him. And then Nils Ioma is going to be presenting hidden requirements for agentic coding, showing how BDD problem personas can uncover edge cases and hidden requirements for better spec-driven development. Hein Michael will be talking on orchestrating AI agents with Java pattern matching. Jenny Ferries will be covering secrets from Microsoft's Agentic DevOps. Yoshio Terada, my Microsoft colleague and fellow Java champion, will be talking about modernizing monoliths with AI without breaking them. Hikeng Zhang will be talking about Agent Scope Java. It's a framework aimed at helping Java developers build enterprise-ready autonomous agents with strong safety and performance. And then Andres Almere will be presenting Deploy to Production with Confidence. Software supply chain security topics will be covered there, and also reproducible builds and CI/CD security. And Christian Christian, will close the session lineup with maintaining legacy applications with AI tools. So we've got a strong lineup ahead for you here. Please do check this out. It's going to be 4 hours, about 25-minute sessions, and lots to do. And also afterwards, check out jdconf.com for the recordings. First off, I'll bring up Josh Long. He's from Broadcom. Most people know Josh. And he's decided to go on a different topic today and cover Spring. So he's going to be covering beautiful Spring AI. And there's just some awesome things happening with Spring AI and allowing you to access all kinds of large language models with Spring in the middle. And I'll bring Josh on to start off on his session.
All right. Good evening. Good morning. Good afternoon. Hi, Brian. How you doing, my friend?
It's going great. How you doing?
Good. Thanks for having me. Glad to see you.
Likewise.
Would that it were in person, of course.
Yes. Well, someday perhaps. This is This will have to be good. So I'm in Las Vegas and Josh is in Lyon, France. So this
Right.
is pretty cool. We're all in different time zones, and yeah. So you're going to be talking about Spring AI and
Yes,
how
sir.
Spring AI can basically bring Java developers into AI capabilities quickly and easily. So
Yeah, that'll be fun. All right, I'll dive right into it. My voice is a little hoarse. It's the allergy season has gotten the best of me, so forgive me for people who are trying to listen. Just trust me, it's the code is good even if my voice is not. Um, my name is Josh Long. Let me share my screen here. Sharing screen. I can do this. I'm going to put the code for everything we're going to look at once I'm done in this Git repository here, Josh Long Attic on GitHub 2025-04-09 Microsoft JDConf beautiful Spring AI. Okay, there's no code there right now because we haven't written anything, but we will. And it is, I'm very online. So if you want to find me, here I am on the internet, LinkedIn. That's a Microsoft product. I think that qualifies. This is my email. I got a YouTube channel, very online, right? And so, anyway, look, my friends, uh, we are in an enviable position right now as Java and Spring developers in this AI world. I think, if you look around, you'll see that we have an amazing opportunity, right? And one of that opportunity, I think, is kind of borne out by a recent study um, that MIT did last year. That the ads, what is going on? The MIT study did last year that finds that 95% of Gen AI projects fail because companies avoid friction. And what that means is they fail to integrate deeply. And they forget, 5% of the projects that have deep contextual integration with existing workflows, those projects succeed. The others are they stop at very simple chatbots and they don't do the necessary work. And this kind of makes sense. I mean, if you think about how a lot of people think they need to build Gen AI solutions, they're building them in Python. Those things, of course, are separate from the very large majority of business logic that runs most organizations, written on the JVM and as often as not in Spring. And so we already have that business logic. It makes a lot of sense to hang these AI integrations off the side of that. So that's what we're going to do is go ahead and build a new application here, start that Spring video. And obviously we have some choices to make. I'm going to use a latest and greatest LTE version of Java, Java 25. I'll just call this an assistant. And what we're going to do is we're going to build an application to support adopting dogs, right? Animals. And in particular, we're going to adopt my favorite dog, a dog named Prancer, whose owner wrote about him in 2021. She says, okay, I've tried for the last several months to post this dog for adoption and make him sound palatable. The problem is he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. But I have to believe there's someone out there for Prancer. So we're going to, I just like to imagine that we're going to build an assistant to help adopt that great dog, right? By the way, this dog did get adopted. You can see why. He's very cute. He was in the New York Times. He was in BuzzFeed and People Magazine, all these different places. And so he went viral, but most people don't find the dog that they want like that. They go to the dog shelter and they interview the shelter for details about the dogs in the shelter there. So we're going to bring in the dev tools. We're going to bring in a OpenAI model, but there's more than 20 different supported chat models here, and more than we need a database, right? So I could use Postgres. But I want also vector store capabilities. And again, there's more than 20 of these, but I'm going to cheat. I'm going to have a vector store that's also Postgres, right? I'm going to use Postgres as a vector store. I'm going to talk to it via JDBC, Spring Data JDBC. JDBC. I'm going to bring in the Spring actuator. I'll bring in I've got the web support. Yeah, bring that in. And I'll bring in the chat memory and I'll bring in, I want to bring in the MCP security, the MCP client support. And I think that's enough, right? And so for now, I guess that'll be enough. Let's go ahead and build this service. And we don't have a lot of time, so I'm going to kind of go through this as quickly as possible. But suffice it to say, we want to connect to the application, connect to the SQL database that's already running on my local machine. So Spring Data Source, we'll say Spring Data Source. The password is secret, and Spring Data Source username is my user, and URL is JDBC:/Postgres, my database. Okay, I'm going to click on this little button here, click on test connection, hit apply, hit OK, go over there. there's my database here, and I've got a table, and you can see we've got a table called dog, and there's our buddy Prancer, who again his oops, I've already adopted him in that demo. Okay, he's got no owner right now. His ID is 45. His name is Prancer, and he's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. Best dog ever. So we're going to build an application to support that process. So we're just going to start by building a simple controller at response body class assistant controller. And I'm going to say ask, and when people ask questions, we're going to answer the question using the Spring AI chat client. This is your one-stop shop for all your AI use cases, right? And I think this code was really well done. It's written by the best people, right? Only the best people worked on this code. Big fan. So I'm going to go ahead and return this .ai prompt.call.content. I'm going to send a user prompt. That's the question that the user will have asked us, and that we will then send to the model. So there's that as well. And when the model gets that, it's going to send us a response back as a string, and we can send it back to the user via the browser. Now, of course, that endpoint in the browser, that REST endpoint or the browser endpoint, is secured right now. So I'm going to disable the security for the moment, okay? But don't think that that's going to stay that way. If I move quick enough, I will definitely come back and reinstate this, and you should definitely have security in your system. There's no reason not to, especially if you're using Spring Security. So I'm going to go ahead and make that endpoint. Now, of course, I want to focus the model on what it is we're trying to do. So what I'm going to do is I'm going to give it a system prompt, right? And I happen to have a system prompt, right? I've got that system prompt, and I'm going to just cat it to the console and then pipe it to the, wait, that's wrong. I'm sorry, everybody. I'm sorry. There, that's better. We're going to do that. I'm going to copy and paste this. And there's the system prompt telling it that, hey, you are an AI-powered assistant to help people adopt dogs from a dog adoption shelter called Pooch Palace, right? And it's got locations all around the world, right? I suppose I should put Lyon in here instead, since that's where I am right now. All around the world, okay? We got some APJ in there as well. I got some Europe, etc. Okay, so there's that. And this is all pretty well and good as well. I think this is pretty good, but the problem is if we try and make this request to the chat model, it's going to forget who we are because it doesn't know, it's a stateless API. The model itself is a stateless API. And when you use Spring AI, it auto configures your different chat models by looking at configuration that you specify via properties. And well, I've already done that. I've already specified an environment variable here, right? So, you should do the same thing, specify an environment variable, but just trust me that it's already done in my machine. So I'm going to use OpenAI. It's going to talk to that OpenAI endpoint, but it's going to forget who I am after the first request because it doesn't have context. And so what I'm going to do is give it user context here, and I'm going to configure something called an advisor. And the advisor is like a filter or an interceptor. It has the ability to sit between each request and response and take note and write it out to a journal, which it can then use to remember what has been said in subsequent interactions. Okay, so let's go ahead and drop these tables. Here we are. And so in order for that to work, I'm going to configure a prompt chat memory advisor. And this will, of course, require storage. So I'll use our SQL database because why not, right? And then this will use a message window chat memory pointing to a repository. And that repository will, of course, talk to the SQL database. So there we are, .builder.build. You can see the builder pattern is quite prolific here. We're going to use that and then that, okay? And I suppose if I wanted to keep it as clean as possible, I would just do something like that, right? There we go. So there's the window. And what I'm doing is I'm saying create a filter, store it, a rolling list of the last 20 messages, store it in the message window chat repository, chat memory, and then store it in JDBC. So it'll give you the last 20, it'll be stored in JDBC, and so on. So this is a very simple example, but it does work. So let's inject that here, prompt chat memory advisor, and we'll add that as a default advisor to all requests being made through that Spring AI chat client. We also want to set up the chat memory, right? So we'll do that as well. We'll say store everything in databases and initialize those database tables. Okay, I'm cleaning up tables as I go along so you can see what's going to happen when I restart this. Okay, let me see. Do I need to reload that? No, let's go. Okay, so the app's up. Let's try asking a simple question. Hey, Josh, ask. Oh, by the way, we need to tell it how to. You can see here, there's a new table called Spring AI Chat Memory. It's got a conversation ID. How does it correlate to which user the request belongs? Well, you specify a parameter like this, a.param chat memory.conversation ID, and then passing in this case, the path variable for the request. Now, of course, what we really want is the Spring Security authenticated principal, okay? So, oops, I forgot to do param singular. Okay. Okay, good. So now ask question. Do you have any neurotic dogs? Right? It's not going to have any good answers for this, but I just want to break the ice and see if it'll work. By the way, I'm using the default model here with Spring AI, which is for OpenAI, which is a very deep thinking one. Maybe I should have switched to a fast one, but I don't remember the model name offhand. Okay, so it doesn't know how to answer that, but you can see it it knows about Pooch Palace, and so it's trying to help. Okay, good. Let's see if it remembers things, right? Let's see. My name is Josh. Okay. Wait for this to go. And by the way, as it's doing that behind the scenes, you can see it's got a conversation ID and then the interactions between the user and the assistant, the user and the assistant. Here's the response. Nice to meet you, Josh. I'll call you Josh. Great. And then I can ask, hey, what's my name? Okay, so there you go. So it's remembered me. So which is nice. I like when that happens. So now we've got that. But it's still unable to answer the question. So we've got data about dogs. You saw that. That data is here in the dog table. What I want to do is get all the data from the dog table and get it into a vector store. A vector store is a data structure optimized for semantic similarity search. And so I'm gonna create a simple mapping here: record dog, int ID, string name, string description. And I'm going to create a Spring Data repository here. Repository, extend list of CRUD repository. Whoop, 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 whoop. Okay, here we go. Good. So there's my basic entity and my basic arrangement there. And when the application starts up, I'm going to read all the data from the SQL database and write it to the vector store. Now, normally you would not do this. You would write things as you go along, but I, for the sake of the demo, have chosen to do otherwise. So I'm going to create a Spring AI document here. And this is a container for data that's going to be written to this vector store. And it doesn't matter what you put in there, so long as you are consistent across your rights. Okay, so dog.id, dog.name, dog.description. And I'm going to write that out to the vector store like so. Now, of course, in this case, it's a very small document. So there's only one document, but a lot of times you have a large amount of text that you want to tokenize. And so you can pass it to, for example, a text splitter, and it'll split into multiple documents, which you then write to the vector store all at once. By the way, this is a document about dogs, so I shall call it document. Now, I'm going to tell the model to consult that vector store before trying to answer questions. So I'll configure yet another advisor. This one's all about the vector store. Voila. Okay. So now it's going to, when it starts up, it's going to initialize. Oh, it doesn't have a table. It's going to fail. I forgot to do that. So we'll say PG vector initialize schema is true. Okay. And now we go here, and you can see there's a new table called vector store, and it's writing it. It's going to OpenAI, back and forth, and it's a little bit slow, but it's going to serialize, it's going to vectorize all the data. And now we can come along and ask it questions like, what was that first one? Do you have any neurotic dogs? It's thinking, right? Okay. Let me see. We got Prancer in there. Let me comment that out while I remember. I don't want this running on every single restart. It says it doesn't have Pooch Palace's current availability. Okay, let's try that again. It should. We can also check that I wrote the data out. ID, name, description. ID, name, description. Okay. What is going on? Let's see. Vector store. There's Prancer. Did I configure the advisor on the actual? I did not. That's the issue, friends. Yeah, I've got it here, question answer advisor, but I need to inject it into the advisor chain. That explains a lot. So take 5. That's a shame. I did that same demo 3 times and it failed 2 out of the 3 times. And I'm in a time where we have only 25 minutes in which to make the point. Sad. Okay, so there's our doggo of choice, Prancer, ID 45. He's described as neurotic. This is a big giant paragraph of text, and maybe that's not what you want. Maybe you want a strongly typed object that you can pass around to other parts of the API. Well, if that's all you want, then you can just ask for it, right? I'll do that exactly like this. Int ID, string name, and string description, for example. It doesn't have to have all of it, but I'm going to take that and I'll say entity. Okay, and I'll return this. Okay, make that request. So you can see I got a statically typed integer. So now I can do correlation and all that kind of stuff. No, of course, in this case, I did actually want a string, so I'll restore that, but I wanted you to see that that was possible, okay? Okay, so as I've been making calls to the backend service, obviously I've been using a lot of tokens. Well, not a lot, but I'm using tokens, right? And it's very important to have observability so you can keep track of which tokens you're using and all that. So I'm going to add the observability support. I'm going to enable it. And then I'm going to go here and I'll just ask the same question. Okay. And while that's working, I can go to the local host 8080/actuator metrics. And you can see there's actually a a GenAI client token usage here. Okay. So metrics, paste that in. You can actually, if I curl this, JQ, you can see which models we've been using, which types, the input and output, the count, right? How many tokens have been used, etc. And obviously, you can send this information to any time series database using Micrometer and so on. So obviously, we've got an observable system here. We've got our chat client integration, but I want to give my model agency. I want it to be able to do things by talking to the world, and the most natural way to do that is with a protocol called MCP. So let's go ahead and build an MCP service. And in this case, we're going to build an MCP service to help schedule pick up appointments for the dog. So we're going to call this scheduler. I'll bring in MCP, MCP server, web, and hit enter. Okay. I'm going to open this up, scheduler.zip. And in the scheduler, we're going to just write a simple component here at service class dog adoption scheduler. And we'll have a date dog adoption pickup suggestion. Okay. Int ID. We'll have the date when and the name of the user making the request. For now, we don't have the user, but we'll figure it out later. So schedule an appointment to pick up or adopt a dog from a Pooch Palace location. Okay. And dog adoption pickup suggestion. And I'm gonna hard code a date in the future. Okay, so that we know it's working. So 3 Corona date days. Okay, and we don't have a good valid answer for that for now, but we'll get to it in a second. And io.println, there we go, and we'll just return. That way we can see it's worked. So this is my MCP tool, and I want the dog ID and the dog name. So I'll say MCP tool param, MCP tool param, and voila. So there's this. I'm going to export this on a port 8081. 8081, I'll say MCP server protocol is streamable, okay? And again, to keep things simple for now, just let's remove security, comment this out, and remove this, okay? And I'll reload. Here we go. So that's up on port 8081. We want to inject that tool and make it available to our client, our agent. So like this, we'll say MCP streamable, MCP client streamable HTTP connections scheduler.url equals 8081. Okay. So we're telling it we want to inject, we want to configure a connection to that remote MCP service like that. And once we've done that, all we have to do is tell our chat client about this remote service by injecting the auto-configured tool callback provider, or TCPV. All right, there you go. And I'm going to then put that over here. I'll say default tool callbacks, TCP. And that's it, so now I can reload. And if I go to the console here, and I can say, well, I don't want it to use its own memory, so I'm going to go ahead and delete the chat memory again, okay? So do you have any neurotic dogs? Okay, good. And let's see, that's one. And then, fantastic. When can I pick up Prancer from the Leon Puig Palace location? Oh. Okay, April 12th, it is the 9th. And if we go to the scheduler, you can see it has given us that response by calling this MCP service. So the AI model has reached out to this remote service to get information that it cannot provide by itself. So this is a great way to plug in the gaps. Now, there's so much more we could do. Unfortunately, I don't know that we have a lot of time to do security right now, but given another like 10 minutes, we probably could. The point is that this is just the beginning. MCP is a brand new protocol. It came out in November of 2024. Super interesting protocol. And, it's one of those things where, I think it's not just the case that we are the best positioned as Java and JVM developers. We are also the best positioned as technologists, right? Here's a study that looks at the performance of different MCP server implementations from February. I don't know if you remember that far back in February, but it was a long time ago. And gosh, it's got to be 2 months ago. And Java does quite well. And this is Spring AI that they're looking at. They're comparing Java and Spring AI to some of these other languages like Go, Node, and Python. Java has the lowest latency and the most total requests. Java, we use the least amount of the CPU. Our RAM isn't great, but that's okay. And look, we do a better job than Go. We do a better job than orders of magnitude better than Node, and we do 2 orders of magnitude better than Python. So Java is a very, very good choice to build these kinds of scalable systems and services. And my friends, you got to remember that these AI models are very good at coding in the small, right? They understand how to help with well contextualized, well defined tasks. And if you understand that, then you have a cheat code for being more productive with these AI models. There was, however, a study that came out last year that suggested basically that while people feel like they're more productive, they're actually not, right? They're actually a little bit slower. So the trick is to find the right amount of sort of latitude to give them and so that they can get something done for you, right? We've all seen these memes, right? This is a meme. Where do you see yourself in 5 years, right? Me. And this one, my entire house is smart tech workers. The only piece of technology in my house is a printer and a gun I can keep next to it so I can shoot it if it makes a noise I don't recognize, right? And then these are all parodies. These are jokes, right? Here's a fake kill switch engineer job for OpenAI where they just want somebody who can splash water on the computer in case things get out of control. I'm not convinced that any of these ridiculous situations are going to happen. I just don't know that these models are quite there yet. You know what I'm saying? So if you are building and you understand how to put together the big system, you're in a really good position. Your expertise matters. And so I want to encourage you, take this moment, build amazing things. We can solve a lot of problems that we couldn't have solved even just a few years ago. There has never, ever been a better time to be a Java and Spring developer, my friends. Thank you so much for your time. If you want to learn more, of course, go to start.spring.io and go to spring.io blog, and also check out the Spring AI community. This is a separate community where we have this MCP security. If you want to do skills, Anthropic skills support, if you want to do A2A and ACP and all these other things, there's these extra modules that live outside of Spring AI, but that are growing by the day, and they're moving so quickly that we can't keep them in the core, at least not right now. So thank you very much for your time, everybody. Have a wonderful JDConf.
Josh, thanks for being here. It was wonderful. Just a little bit of trivia to remind me of. I used PG Vector. People forget that.
I can't really hear.
Oh,
right.
People forget. I hope everyone else can hear me. People forget that ChatGPT actually runs on Azure and uses Postgres when it's keeping track of your chats. So a little bit of trivia for you there. Interesting. Oh, thank you, Josh. Really appreciate you coming on and taking the time from Lyon with your allergies kicking in. And next up, we have Nils Yoma. Nils, great to see you. Hey, Nils, how are you? Great to see you. And basically, for the next session, I'm really interested to watch this one myself. This is going to have Nils Yoma. He's from MHP, a Porsche company. Pretty cool. And you're going to talk basically how context is very, very important in coding agents, and how BDD problem personas can help with that. So without further ado, I think I'll just kick it over to you and let you get into it. Thanks.
Yeah, thanks. Thanks for having me. I wanted to be in Asia currently, but my flight over Dubai was canceled. So now it's, I think, same time as for Josh, early in the morning. I will rush a little bit because I don't have so much time. Again, thanks for having me. So as you said, I'm from MHP. MHP is a Porsche company. We are in Asia. We are in Shanghai, in India. So if you want to apply for a job, whatever, check on the page, because we are doing good business currently in the automotive sector and looking for talents. So a few words about me. Happy to be here on the JavaConf. I was Java developer. I was Java developer of a backend team, never seeing any user or stakeholder. So I decided to be agile coach, and now I'm working with AI. I like to create card games. I will show you one card games. I will show you how you can use it with AI. And I think collaboration and co-creation is really important. And this creates value between, at Agile Software Project, if developers talk to users or stakeholders. I will tell my story. I will tell my story about AI and vibe coding. So maybe I tried it, as most of you. I mean, this is a developer conference, and I tried vibe coding, Visual Studio Code, Google Anti-Gravity, and GitHub Copilot. And to be honest, at the end, in the beginning, I was fascinated. In the end, I was a little bit frustrated about the results, because the app or the AI wasn't doing what I was doing. Then I tried last winter spec-driven development. The results were much better. I was less frustrated, but I was not really happy about it, but it was still fuzzy what was coming out there. And then I created my own AI workflows for Visual Studio Code and Google Anti-Gravity, and I will show it to you today. So I was able to develop my own software. I talked to the CEO of MHP, and now I'm allowed to digitalize risk-free internal processes, for example, tender automatization that we call websites, analyze them, and I use AI to build these workflows. Oh, talking about the CEO, I get a call. I shouldn't tell him that I can work with AI. Let's see what he's doing. I forgot to lock my screen.
Nils, stop. Why are you teaching them about collaboration? I just bought 500 licenses for an AI coding agent. It doesn't need vibes. It needs a prompt. I'm firing the whole department this afternoon. You're the only one staying because you're the AI guy. Go ahead, tell them they're obsolete.
Max, you cannot do that. Developing software you want to do with AI, so I think we have like it's only an 80% solution. I mean, these are our core processes. We shouldn't automate that with
Liz,
AI.
Stop. Why are you teaching them about collaboration? I just bought 500 licenses for an AI.
So let's see what the answer is.
News. Nonsense. The AI is faster. It doesn't take coffee breaks or complain about agile ceremonies.
Max, I really can understand it, but do you really think we should kick out people? What's the problem with your software? Why do you want to get rid of people? Be honest to me.
Fine. It's a mess, Nils. The software looks like Swiss cheese. It's full of holes. We have massive release pressure, so we just push code. Nobody tests problem scenarios because that's the tester's job. The stakeholders say they don't have time to talk, and the developers say the requirements from the business arrive too late anyway.
Okay, I get it. So the software looks like Swiss cheese, and we are behind schedule. So that's why you want to kick out people. I totally can understand it, but I exactly had this problem with my teams, Max. So give me a chance. Let me present my solution. Later you can figure out if you really need to kick out the 500 people, because I think then we would be as generic as any other company.
All right, Nils. You've got 5 minutes. I will watch your agentic demo. I will see if these problem personas can actually fix my Swiss cheese. But let me be crystal clear. If this demo doesn't show me 100% coverage beyond the happy path, if it doesn't prove that these human specs make the AI better, I am signing the termination papers for every single developer the moment you log off. The pressure is on. Show me the code.
Okay. So code, 5 minutes I have. So, okay, Max is my CEO, my story. I had a similar challenge as you. So my product owner said, for example, the software felt like Swiss cheese. She doesn't want to click on anything because everything which was not on the happy path felt like really risky. And we had deadlines to meet, so she was aware of it, but we were rushing through it. So she always had like the departments delivers the requirements late. So I did something to help the department. So I was on site. So I did some brainstorming with the department. So here's a story of our project, and I visualized it. So this is the happy path, the black one. This is domain storytelling. This is a tool. And we did a brainstorming session where we were putting sticky notes, red one and orange ones for problems and for errors. And then one junior was taking over and created the same thing based on our input. And we both were pretty lazy, so we were putting it to an AI. So we had an AI like ChatGPT. It's called Co-Driver at the company. So we got a list of BDD scenarios. And that was actually pretty nice. I hope I don't have to explain to you BDD scenarios. So it's this given when then syntax, and I was getting 20 BDD scenarios, just uploading the image. And I went to the stakeholders and they said, like, Niels, 10 of your scenarios are pretty nice. We can use them. 5 of them we have to optimize, and 5 of them are really shitty. Why do you have like this shitty scenarios? They're way far away from the reality. But I was pretty happy because I had before this problem that I don't have any scenarios, and like this is a nice scenario to give it to the developers, and they can create user stories, or maybe they can unit tests, they can do test-driven development. And it was really nice, and I had to laugh because there's 5 scenarios where the people in Germany were a little bit strict to me. They never could create any scenarios. I was really happy that they said like only 15 of them were usable. So this increased a little bit our software quality. Normally, if I would have more time and I would do it on site, this is like a session where I now would let you create a BDD scenario. And this is always really nice because if you see these images of a conference here, you can see people who are not really into software development, because mostly I talk to agile people. They will create scenarios together, and after a few seconds, they understand BDD scenarios. So my learning is always, if now people create and sort BDD scenarios with other people, that people are doing pretty good to do it, and agile artifacts are really good to understand for humans as well as for large language model. And 73% of all American white-collar workers want to work with AI, but they just want to keep the control. So I think agile artifacts are really nice to keep the control, because we can understand them. Large language models are trained with text. Agile artifacts mostly are based on text, so they are able to create it and read it. So if we want to create agile artifacts, we have a 95% success rate. Creating, for example, user stories is not about the context, but it's about the shape and about the structure that everybody is able to understand it. But my teams were a little bit resistant. So I had two teams. One said, like, we only develop. So we had to divide the artifacts for them and they used it, the BDD scenarios. And the other team said, we don't dare to ask. We are afraid to ask the users and stakeholders because users and stakeholders in Germany can be pretty grumpy. The team had like an Indian background. They were really nice and polite, so they were not really asking. So I created a card game. The problem personas, and I will explain it to you, and then we will try it out with AI. So I created out for you a small exercise you can follow, and then I will show how it works in Visual Studio Code and in other tools. So I created some cards because I wanted the people to speak up, and I created some green cards here, for example, Thorsten Tester. So these are really positive test personas, and I created some yellow cards that are problems personas, which challenge your requirements. They are not so happy. They are chaotic, like this Niels. And then we had red cards, people who really try to harm your software. My idea was, if you have a requirement, that we will pull these cards, two people will pull apart, they will check out the requirement, and then they create a scenario, a BDD scenario based on the persona for a problem on error path, so that we get a little bit more knowledge about the software, about the domain, and we create better software. So I created here Thorsten Tester. He is a test manager, and he will put ABC, for example. If you order coffee or have a field, you will put ABC coffees and see that the software is giving you a mistake. We have compliance. Clara always knows or remembers that in Germany, GDPR is really important, that the data is saved. Then we would have accessibility. Alex, you will check, for example, that people with green or red disability can use the software. This is really important in Germany too. Consistent Connie or always right Aya, they know everything about the process, and they will try to figure out edge cases or things which are not working so often. Then I have Niels Newby. I don't know, maybe you realize this face when I'm talking about it. So he is always a little bit unsure what he's doing. He's clicking on the wrong buttons, and you have to go back and you have to recorrect it. Cleanup Carl, he's like inspired from a project as well. He has to open console, fix the database if there are wrong data in it because we already received it. Poolside Phil, he's working from Portugal like a working colleague, and he has a bad internet connection, so his connection drops and will be restored. So this is a scenario which we should discuss as well. Or Confused Conrad, a little bit older boomer worker. If something doesn't work, he will just click randomly somewhere or close the app and open it again. And now to the red cards, Malicious Max. He already canceled the company, so he really wants to harm it, so he could steal data or do something dangerous. Chaos Klaus, he's our IT administrator. He never studied computer science. He doesn't know what he does, but he goes to lunch and the database is down, so then we should get an error message. Or third-party Theo, he's changing the APIs and changing the data quality without letting us know. So these scenarios we should cover in our software and we should discuss it. Normally in a conference, I would let you do an exercise, but I will skip it and we will just do it remote, not remote, we'll do it with the AI. Normally you would get a scenario and you should, a requirement that you should create a scenario like this. So for example, ordering a coffee, this one would be here. Thorsten orders a cappuccino and clicks twice on order now. Only one order is generated, or he will order maybe not one coffee. In this case, he will order ABC coffee or whatever. And this could be really nice because if we do vibe coding as well, I think we have these blind spots which we should which we should close. So I would show you how to do it. So basically now, if you would be on site, you would have a scenario, you would raise a card here, and then you would be able to explain it. So then always my learning is incorporating gamification. The problem persona is really fun for the people. So first they create the BDD scenarios, and then they creating error BDD scenarios with people sitting next to them they don't know. So this is why agility works, why agile artifacts work, why gamification works. But now let's dive into the AI, and then let's come to the demo. So the cards and the scenarios. So you can scan this QR code here. I will leave this open for a few seconds. Okay, and now let's create it together. So when you click on the QR code, you will come directly to the BDD custom GPT, or you can go here to my GitHub repository and you can click here on the link. That's basically the same. And then the next one would be that you just paste in here any random user story or any random requirement you have. And I don't put in here any system prompt. I just put in here like a requirement as a customer. I want to order a coffee and pay for my favorite coffee, so on and so on. It's not a good user story, but I don't type any prompt here and saying like, hey, I'm a business analyst or whatever. It's just working. So and you can follow this link. You can try it out yourself. And this what makes basically the people do. It will be happening here in the AI. So here you can see persona Niels Newbie is creating a BDD scenario, and his persona is in the background. His image is in the background, so we know exactly who he is. And Niels, for example, here has a cappuccino in the cart, and the payment page shows unclear instructions. So Niels cancels the process. Okay, this is not a really good scenario, so we can skip it. But here Niels is ordering a coffee, and then he's going to the checkout, to the payment page, and then he's clicking back in the browser page, and the cappuccino is still in the shopping cart. So this is maybe something where we now could create in the next step with AI an automatic test out of it. Or here Konrad, let's skip him, but we can check Torsten here. And Torsten, here we can see he enters like, is it 10,000 or 100,000 cappuccinos? So here we have the BDD scenarios, which we could put to our vibe coding, to our specs, so we can cover them as well. And my experience is if we do it, the AI is pretty good in recognizing it. So this one, you can use it, it's free. You can use it, it's free as well as everything else. But if you want to show it to your manager, whatever, this one, he doesn't need Visual Studio Code. That's why I used it, and we can see the images. So now chapter 6, short demo in Visual Studio Code in Google Anti-Gravity, and then we can see how it works in Google Anti-Gravity and the custom agent. So I was making a custom agent out of it for Google Anti-Gravity and for Visual Studio Code. I downloaded here like a random planning poker app. I wasn't coding it myself, but I thought everybody of you is aware of planning poker. This is Visual Studio Code. And when we check here under the agent, we can see we don't have here anything special. But if I go back to my public repository here and scroll a little bit down, you can use the card as well. We can just click on this button, Visual Studio Code install, and then we create, here we add this custom chat mode, which is really nice. So we know we can use agile artifacts. The LLM can use agile artifacts. We can use agile artifacts. And now here we can see we have the problem personas chat agent. It's automatically saved with one click here in the area. Now I could paste in here my requirements, but I think you experienced already how you could paste in here requirements. So what I can do, I can just put in here the source code of the app, and then I have to select, maybe let's try if Haiku is working, or I think GPT-4.1 is working, and I have to type in something just that I can press the next button, but here it's just do it. And then now I'll put in here the source code. This one is already mentioned, so I wasn't putting any code and any comment, and now I can see it working, and we can use it for refining requirements, or we can use it for basically for create here scenarios based on the source code. Let's see if it now works. It should be. Maybe that's the live demo thing. We can scroll here a little bit up. Here you can see it. I did the same. So here user stories are created. GitHub doesn't show you any images, so they're hidden here, but here other tools can show images in Markdown, but here you can see the scenarios that Thorsten, talking about planning poker, clicks on the card 13 times here in the top, so we shouldn't do it. And here he votes a -5, so this are things which should be covered, and this is based here on the source code. Live demo not as fast as we should be. Something is happening here in the agent and the features, but that's the way it is. I can show it to you in Google Anti-Gravity as well. Same app. Here you can see the images. So here I can annotate the workflow. So this is BDD problem personas. Here I don't have to type anything. Here I can take the source code, pull it in, and then we will create problem scenarios based on the source code or on the requirements. Of course, I can put in some things here as well. So you have something which you could paste in if you do vibe coding. You can put it to your app or to your specs. This will, in my experience, really create a better quality because the large language model is really good to understand it, to generalize it, and so build more bulletproof software. And if you have an MCP server, so what I always doing is I putting them to the not to the browser, to the agents that like verify that this one is working in your app, and maybe 50% of the time some functionality is missing. So the agent is understanding what this scenario is and then tries to click it on the working software and then figures out that there are some implementation gaps. So this automatically increases the software quality. Or you can do the next step. Hey, do unit tests based on it if you want to work in smaller steps, and if you want to work here with the custom chat modes as well. One thing I realized is when I work with the ChatGPT, I show it to users and stakeholders, and they like this personas. It really gets their attention. It gets my attention. So I always can talk about them, what I did, and then they come up with ideas what they could create with agentic workflow. So this is always a nice opener. Yeah, you can find anything on this website. The cards I presented here, you can find them, and the images stored as well. So here you can see the portraits, for example, with transparent background. Here you have Thorsten Tester. So this is how the things will be shown. It gives them a little more character, gives them a little more culture, and the prompts are here as well. So basically here I told you can click on it and you can install it. But if you use other tools, because this one works only for GitHub Copilot, you can go here to the custom folder, and you can go to the custom chat modes, and here you have the persona chat mode prompt, so you can put it into IntelliJ, for example. I think was not able to install, but here you can just copy it, paste it, and then it will work in your tool, in your internal environment. Yep. Nice. So what I really like, because I'm a little bit ahead of time, this is really nice. So I really like to work with these personas, because when I was doing vibe coding, I lost a little bit track, and I like if people or things talking to me and I could see images or faces. Okay, let's try to wrap it up. That we did. Last words. Yeah. AI makes the work easier as long as humans remain in control. Agile artifacts are really good for it. Proven agile artifacts are beneficial for both humans and large language models. Both are trained on them. 94% accuracy in user stories. So I can highly recommend, if you do vibe coding, if you talk to people, if you create something, do small steps, use agile artifacts. They are proven, they are working. Personas reduce the barrier of talking to people, and role plays are funny, and personas help to deliver bad news. And spec-driven development needs BDD scenarios. I would love to show it to you, but I only have like 25 minutes. So vibe coding and automatic testing in the browser that's really good at this persona, at this BDD scenarios to your specs, or let them verify it, really increase the software quality. And let's see what Max is saying. Max, it was a little bit more than 5 minutes. I hope it's okay for you.
Nils, you can tell HR to shred those termination papers immediately, because that demo was a total wake-up call regarding how we use technology. I saw exactly how your problem personas like Torsten Tester and Chaos Claus caught the hidden risks and edge cases that were making our product look as holy as Swiss cheese. It turns out that when we use high-quality agile artifacts to guide the agent, we actually hit that 94% accuracy you mentioned instead of just automating our mistakes. I don't want to fire the developers. I want to scale this human-in-the-loop workflow across the entire organization immediately, so we can finally start turning those uncomfortable insights into real commitment and solid code.
Nice. So our demos have saved 500 working places. So this was pretty fast. I give this one here like a few seconds. This one here is a GitHub repository. Scan it and everything will be for free. I think this one is streamed on YouTube. Is it now too fast for you and you don't have your mobile phone? You can scan it later. And if you have more questions, if I should present a workshop in your community of practice and you want to have a workshop of it, or you have some questions, scan this QR code. It should redirect you to my LinkedIn code. I'm happy to connect and talk to you and get your inputs. Maybe you have great ideas now what you could automate with custom chat mode and ChatGPT. I'm pretty curious to learn about it.
Nice work. Great. Hey, I do want to say one thing. I hate to break this to you, but I think, not sure entirely, but I think your manager might be AI. Just so.
Are you sure? I'm not 100% sure. Should we count fingers?
To be fair, he does actually remind me of former managers, but I think it's AI. Just a few slides that were in there. Hey, I did have one question for you, which is somebody was asking you how you actually, what tools you use to build your slides.
Tools, but I create images with Midjourney, and then there's something like DID Studio where you can animate the things, and then it's just PowerPoint.
Nice, great presentation, great content, of course, as well. So thanks for joining. I did want to mention we're going to bring up another slide with a QR code. We do have a survey that we'd like you to complete as well. So please do fill out that survey when you get a chance, just to let us know how we're doing. We always value feedback when we're doing these things to make them the best they could be. So thanks for doing that. And thanks to Nils. Thanks to Nils for his session. That was great. Next up, we're going to be talking to Hein Michael. And Hein's going to be talking about orchestrated AI agents with Java pattern matching. And that is, orchestration is such a hot topic right now. What happens is everybody just starts using commercial chat services and they run into a problem with tokens. And it's so, orchestration is so key because there's a lot of there's a lot of interaction with a large language model or a system that uses the large language model that doesn't necessarily have to use the latest, best models. You can choose an older model. Sometimes you don't need a model at all. Just, what's tomorrow's weather? You can check a weather service. You don't need a model for that. So Chaim's going to take us through orchestrating AI agents using the technique with Java pattern matching. So
Wow. Hello, everyone. Can you hear me?
yes, yep, can hear you great. How you doing?
You see me? Okay, now I will share my desktop. Just a moment. I want the entire screen. So you can also see my entire screen. Is sharing your screen okay?
I don't personally see it. I'll just check with the folks if somebody could mention the chat. If they can, there it is. Okay, I can see this.
Okay, yeah, I'm on the wrong screen.
Awesome.
Just to verify, and now you see my slides and you see me, yeah?
Yep, everything's working.
And just to verify, here is one ID, here is another ID, and again, my slide's correct. You saw me?
Yep. I'll just do the standard thing and say make the IDs bigger. That's all.
Okay, I will stick mostly with the slides. We don't have lots of time. Maybe I will just jump over. You already have all everything. I mean, I prepared all code samples as well as the slides. So if you just visit my blog, blog.lifemichael.com, or scan the QR code, then you will get to my blog, and there the first post is the post for this talk, and you will find the code sample and the slides, so you can play around while we move forward. Okay, so should I start, or how does it work?
Take it away. Yes, thanks.
Okay, so wow, I'm alive. I'm live, alive. I'm so excited. Wow. Okay, well, let's start. So here it is. So my name is Chaim Michael. I'm from Tel Aviv, and I'm super excited because, to be honest, of all programming languages, I think Java is kind of my mother tongue. Even though I started coding before, only when Java came, it became my professional way for making my living and so on. But I'm also into many other programming languages. I'm from the old generation, the one that used to code and still continuously code. And my passion in life is mainly teaching. I enjoy teaching, sharing. I have a YouTube channel, I have online courses, and I also enjoy building, creating. I have huge experience long time ago, 2001, 2008, mobile games, server-side in Java, but also in other domains. And recently I found that joy of building stuff again, and can share that I'm building today lots of products, services, kind of zero human companies. And of course, spec-driven development, a bit of vibe coding, many programming languages. This is my fun. But today, my talk is about a super exciting topic in programming known as pattern matching. Now, you can find pattern matching in Java, Kotlin, Scala, Python, just name it, C#, of course. And since that, this super advanced topic goes well with orchestrating AI agents. So indeed, I moved to English, and English is my main programming language today, but still there are cases where I instruct those machines to do things in a specific way. And when it comes to orchestrating AI agents, pattern matching can assist us writing code very, very clean, easy to understand, easy to maintain, and trust me, you don't want to make things difficult for the machines, because the code it will be simpler for you to understand, but it also will be simpler for the machines to do their work. So here is at least one reason why we should care about pattern matching, know pattern matching, and know how to use it effectively when orchestrating AI agents. And as I said before, it can be in Java, but it can also be in many other programming languages. So let's start first with understanding what pattern matching is, and then take a look at a few samples where we can use it effectively in order to orchestrate AI agents we work with, or to be more precise, our code is responsible for working with. So in a way, many will say that pattern matching is kind of switch case on steroids, and yeah, there is something about it. You can get that feeling, but it is by far more than just supercharged switch statement. And as I said, we will start with a small overview of what we can do with pattern matching. And you can take those code samples, the code samples that are relevant for this part of the talk. You can execute them using IntelliJ. The other part where we talk about pattern matching in the use of orchestrating AI agents, you will find the code samples ready for use. You can use VS Code, or I was using Kira, which is a kind of a VS Code plus few more plugins. Or you can just take the code and execute it on your end without the code that use AI agents was developed using LangChain4j. You can use it with any AI model you want. There is nothing specific, special about the AI agents. Those are very simple. The purpose of this talk is understanding how to use pattern matching in orchestrating AI agents. We're not going to see fancy AI agents. This is not the purpose. So the simplest possible scenario, and you can see on the bottom, I also specified the exact file you can use to execute this code sample. A simple use of instance. Well, yeah, you can see that in this code sample, we create an object from the class dog, and then using instance of, we immediately, take a look at the new way, we immediately get a variable assigned with the reference to that object. We don't need to do any casting, but okay, this is nice to know about. This isn't something fascinating too much. Let's move forward. Now let's take a look at this code, because this code sample shows you how we can easily use pattern matching to avoid code that check the type and then do the casting. Just imagine if we didn't have pattern matching, probably you would have seen many more code lines, including checking with instance of whether it is an object of a specific type, and then the casting and so on. And look how we avoid all of that. Simple switch case, and then according to the type. You see, in this case, when hello is invoked, a reference for an object of the type dog is passed over, and then the case that will take place is the one that fits in terms of the type, or if none of the three options fit, then we have the last case that will take place. Okay, this is nice. So let's move forward. So in this case, of course, you can see that we can expect, because this is an object of the type dog, that we will get a call to the how function on that dog object. And as you can see, we get something that is very simple to maintain. And I think that this is the point where you might start thinking, hey, we can use pattern matching in order to write code that works with AI agents, and maybe shrink the code into something that is simpler to maintain. And remember, if it is simpler to maintain for you, it is also simpler to maintain for the machines. And when it becomes simpler for the machines, then the they do their job better. And this is from my experience. I want everything to be simpler, not just for me, but also for the machines. Because eventually the machines do the work, we no longer code, you know that already. Okay, now there is a requirement why eventually we will find ourselves using sealed classes, and the requirement is for a completeness. And when I say completeness, I mean that if we take a look at the previous sample, the switch case must cover all cases. So in order to achieve that completeness, and this is the same that applies whether you work with C#, Kotlin, Scala, the same principle. So eventually, either you have a case for default, meaning all other cases is covered, or you cover all cases. So covering all cases, that can happen if you use a sealed type. And this is where it becomes even more of a tool that fits a specific possible outcomes, a specific set of types. So just start thinking about working with several AI agents, and you know that OB can be a type out of a specific set of types. I mean, this, for instance, will compile successfully only if we indeed cover all possible cases. And that can happen only if we use a sealed type. Let's take a look at the code itself in the IDE. So we're talking about sealed program. This is the code. Now, as you can see, I will make it bigger. The types we have, animal, dog, tiger, cat, human. If you look at the type, then you can see that animal is a sealed type. So if you're not familiar with what does it mean to be a sealed type, well, this is also something that actually exists in many programming languages. It means that you specify the types that can inherit or can extend or implement if you define a sealed interface. So in this case, this code actually says that only cat, dog, and human can extend animal. You can't just define it in class and say that it extends animal. You can't, because animal is a sealed type. Only those types, cat, dog, and human, can extend animal. And because of that, if you go back to the code itself, the completeness requirement is kept. So we cover all cases. In this case, it's not possible to have a type out of nowhere. So because of that, you have a full coverage of all cases. So that's why using sealed type is very common when using pattern matching, because it allows you to cover all cases without having the need to refer to the default case. Here in this code sample, I actually refer all cases. So remember that completeness requirement when you work with pattern matching. Now, back to the slides. The guarded patterns. Here is how pattern matching become very sexy, because it's not just switch cases. I can specify using the when operator specific cases. So when the area of that rectangle is bigger than 20, do one thing. When it's not bigger than 20, do another thing. So this is how you can use pattern matching to reflect a complexity of various conditions. And instead of having lots of if else inside other if else and switch cases and so on, you have something very clean, concise, something you can easily maintain. And you know, most of our work is maintaining. developing new features, fixing a bug, creating something new from scratch. Yeah, that happens, but this is not the majority of our work. Our work is mostly maintaining. So the more concise our code, the more sexy it is, the more simple it is to maintain. This is the real magic, in my opinion, for us, the humans, but also for the machines that eventually you use to write the code. So we want our code to be that way. And now there is the deconstruction. Now, deconstruction is about taking an object and deconstruct it and get outside of that object values it holds. Now, this is something you know from JavaScript. You also have it in Kotlin. You also have it when using pattern matching, because you can deconstruct the object and extract those values you want to do something with. And that turns the code even to something more sexier, very concise, simple to maintain. Because look at this. This is a very simple demo for deconstruction. Here you have an object of the type rectangle, and look how simple it is to deconstruct the values of width and height. Because, well, when we put OB, instance of rectangle, and then specify WH, then it means that we want to take that object that OB holds its reference and deconstruct it and take out of it the value of the two values it holds, the two values we could imagine that if we were creating an object of that type, these are the two values that will be passed over. And here you can see another magic, something relatively new in Java, but it exists in other programming languages. Sometimes they call it with different name. In Python, they call it data class. Here we call it record, but this is the same principle. When you take that magic keyword, record, or as I said, in other programming languages, it can be case. In Scala, it's case. In Python, it's data class. It's the same principle. When I put record instead of class, it's not just it's not that I'm creating a new type. It's a rectangle. Yeah, it is a new type, but also something else happens. I automatically get lots of the definition of many methods and a constructor underneath, and those are automatically being used, for instance, for the destruction of the object. So we have an object that represents a rectangle, and we deconstruct it. And by deconstructing, in this case, I mean taking out those two values that were used when that rectangle was created. So again, you can just imagine how, using this deconstruction, we can write smaller code, simpler to maintain, and that becomes a magic. Even further, even more than that, when we are dealing not with a simple pattern, but something more complex, like think about the type color rectangle and point, and then in that deconstruction process, we actually extract not just those 2 points that we used to create that color rectangle, but also the color. Everything is deconstructed, and we get those values and we can use them, which is very neat. And if you're using a switch and you don't need a variable, you can just put a underscore to turn the code into something even simpler. But the real magic comes when you use this deconstruction together with the switches, and we'll see it shortly. So that was the first part. We saw pattern matching in action. Now let's move forward and see how we can use pattern matching when orchestrating the agents. Now, you already have the code samples on your end. Now, the code samples I prepared for this part of the talk were prepared using Cura. So Cura is actually a variation of VS Code. So when you open those code samples, you will find lots of text, the specification actually, that explains exactly what happens in each and every code sample. And you also have the chatbot in that ID, Kira, and where you can interact with AI to get more explanation about what exactly happens in each one of these code samples. But you can also ignore Kira, just look at the code. You can use your favorite AI, your favorite ID to get the additional explanation. So let's start at how we can use pattern matching in orchestrating the AI agents. So the first sample, the simplest scenario I can think about, and the code you see is just the bottom line. I didn't want to overwhelm you with code. I mean, we can go to the ID, but it would be too much. Look at the most important part of you see on the bottom of every slide, I write the name of the project. So you can just go to that project and find those files and the additional files. So what you have over here is the simple program main, and we work with an agent, and we call chat on that agent, send prompt, and then we get something back. Now, that something that we get back is something of the type agent row result, okay? And then when you call to agent result, you get something of the type agent result, and then you pass it over to handle. Now, let's look at the code. I don't want to execute, I just want to look at the code itself. The code for orchestrating agent results. So, just a moment. This is the other sample. There it is. So look at agent result. In this case, agent result is an interface. And as you can see, it includes a definition of 3 other types that implement agent result. And agent result is marked as a sealed type, which means that only answer, clarification, and error are types that inherit or extend, in this case, implement agent result, and that eventually is reflected over here in the code itself, because we have the completeness requirement, and when handle is invoked, we use pattern matching to identify what exactly happened and react accordingly. So in this very basic example, when handle is invoked and a reference of an agent result object is passed over, we use pattern matching to understand exactly, is it an object of the type answer or clarification or error? So the output of handle will be accordingly. Now, if you think about working with an AI agent, using pattern matching, we actually put some order. The result of that agent can be only one of 3 options. And then we take the chaos of working with AI and turn it into something that is more organized and simpler to work with. So this is the first step of putting some order in that chaos we get when working with AI agents that return various objects, various values, and here, instead of a chaos, we have something very organized. The reply from that agent can be only one of 3 options, for instance. So this is the first sample for using pattern matching. Now let's move forward to a few other samples. here is another sample of common scenario where we have pipeline of agents. The first agent is planning, the second codes, the third provides some review, feedback, and using pattern matching, the code becomes significantly simpler because as you can see, the real magic, well, it happens, well, it depends, but it starts, in my opinion, from step, because if you look at step, then you can see that we have a pattern matching to check what is current. So in this code sample, we have the type agent message. We also have planner agent. We also have coder agent. But these are the options. If you look at the code itself, for this one, this one, yeah, this one. So you have the type agent message. It is an interface, but it is a sealed interface. And as you can see, there are specific types that are allowed to implement agent message. These are the types. So we can use pattern matching without having the need to specify the default case. And then we can get code that handle all cases. So if I look at this definition of step, so current, well, it can be a plan request, it can be a code request, it can be a review request, and for each one of these cases, there's something specific that will take place. The code becomes simpler to maintain. And this is the magic about using pattern matching with multiple AI agents we need to orchestrate. Let's go back to the slides. I still have a minute or two. Branching delegation, another scenario, another pattern you can think about. You have functions such as dispatch, and it needs to direct the flow either in the direction of using an agent for translation or using another agent for summarizing. And in reality, there can be more cases, more agents, and then you use a simple switch case pattern matching that cover all options. You know for sure it cover all options, and refer all of those cases, and you get a router, depends on which language you talk, component that is responsible for delegating the flow to the specific direction, to the specific AI agent that should take place. We are almost out of time, so let me just finish. There are those cases in which we work with multiple AI agents and we try and it fails, so we try again, but we want to limit how many tries are we going to have, how many times we are going to attempts are we going to have. So we can use pattern matching as long as the number of steps, the number of attempts is not hasn't reached the maximum we set, and if approved, great. If the case is rejected, then you can see that I call the function code one more time, and then this is the same code that is invoked in the first line of this function, but that retry again and again is not unlimited. At some point it stops. Another sample, when you want to work with multiple flows, maybe they're separated threads, and then you want to wait for all of those flows to return back, and then maybe use another agent to choose the result you want to continue with. Again, you can use simple pattern matching, as you can see, just for choosing which is the one to move forward with. And again, you put some structure in all of that eventually turns the code into something simpler, not just for us humans, but also for the machines, which is very important to take care if you want the machines to do a good job. This is my experience. Okay, so that's it. You have the blog. I give you my WhatsApp number if you have any questions, my email, and now I will be glad to answer questions that you might have. So,
Thanks.
Yeah.
Okay, great. We did have one question, which is where can they find the source code for your examples?
If you go to my blog, the first post you find there is the post. Now it is for this talk, and there you will find the slides and also a link through which you can access all code samples I overviewed, and then you can just try playing around and see how it goes on your end. And if something is not clear, you can be in touch with me. You can also ask AI. AI knows how to explain multiple times. The best teacher, also something that is about to replace us. Okay, that's it. I'm with you.
It's pretty good at pattern matching as well. Thank you, Chaim. It was really, really valuable stuff. Orchestration is so important when you're building a resilient system. So thank you.
Thank you.
Yes, thanks. Next up, Jenny Ferries, my Microsoft colleague, is going to be talking about secrets from Microsoft's Agentic DevOps transformation. And actually, I've got a similar session, actually related session, in the EMEA time zone in the next segment, which is coming up in a few hours. So I'm very interested to hear more about this. Just going to talk about how specialized agents can be used throughout the development workflow and the actual experience that her and her team had implementing them. So welcome, Jenny.
Great. Thank you, Brian. Excited to be here.
Great. Yeah, I'll just let you take it away.
Sounds good. I'm a principal software engineering manager at Microsoft on the One Engineering Systems team. We build the internal developer platform that the rest of Microsoft ships on. Today, I'm going to show you something real, not a concept, not a roadmap, a workflow that we run in production every day. And by the end, you'll have everything you need to try it yourself. And if you're a Java developer, and I assume you are because you're here at JDConf, you know this loop pretty well. Dependabot opens an alert, you update the dependency, something breaks, you fix the break, write a test, open a PR, get it reviewed, merge it, next repo, same fix, same loop, over and over again. And if you're lucky, it's just a version bump. But the ones that cost you real time, the one that eat you up every week, aren't the version bumps. And as you know, not all CVEs are version bumps. Some actually require code changes. So here's what happens. Dependabot bumps the version, the CI is green, everything compiles, maybe auto merge even ships it, and then production throws a forbidden class exception. But your CI was green, but production wasn't. Now multiply that by however many repos are in your org, that's months or even years of developer time on work that isn't building anything new. So let's talk about why now, and why now we can actually at scale remediate security vulnerabilities and issues, because 4 things converged. The 4 things that came together was, 1, the models got dramatically better. The context window went from a keyhole to a room. The agent runtime made massive improvements. GitHub Copilot CLI gives agents real project awareness, your POM, your build, your whole repo. 3, the interaction framework. How you work with agents matters just as much as what they can do. And 4, agent skills, reusable expertise and markdown that turns a general purpose agent into a specialist. Let's walk through each one. We'll start with the models. Today's models are the least capable models we will ever use. And that sounds dramatic, but let's actually look at the numbers. 12 months ago, Sonnet 3.7 scored around 23% on SWE-Bench Pro. That's a benchmark of real-world novel coding tasks. And I remember using Sonnet 3.7 to do one of our big migration efforts here at Microsoft. And I was so excited, but we could only cover a very small portion of what the actual migration was for the auth code. But it was amazing we could get that much done. It was so exciting. Today, with Opus 4.6, it's scoring 45%, which is almost double on the SWE-Bench Pro. The context window is 1 million, so it's 5 times more than what we had with Sonnet 3.7. And that's where you can get chaining tool calls. It can hold the context better. It can reason through multi-step processes and tasks. It can just do things that weren't even possible back even in July. And now we have Mythos on the front door. The preview there, I was just catching up on the system card for that. It's around 77.8% on SWE-Bench Pro, and it's pushing the boundaries on what we even thought was possible. And here's the thing that really changes for us is the context window. A year ago, 200,000 tokens, that's like looking at your code base through a keyhole. And now you might see 1 file, maybe 2. And that's when you may have had to build your own sort of way for the agents to work together. Maybe you had a PR review agent, maybe you had a kind of like a dev or a PM agent, and you kind of organized everything on your own. And now the models have that built in, so you don't have to worry about that as much. And they can just handle the context. And now with 1 million context window that we have in Opus 4.6, it really is like looking through the window and seeing the whole room. So now I can see your whole project, a lot more of your code base. And so the model is not the bottleneck anymore. The bottleneck is actually what you feed it and what you give the model. So let's move to the second big improvement, was just GitHub Copilot CLI, the agent runtime. GitHub Copilot CLI isn't just autocomplete in your terminal, it's an agent execution layer. It can read your project structure, your pom.xml, your Gradle build, your dependencies. It can run tools, edit files, execute builds, and create pull requests, even work with different MCPs like ADO MCP, GitHub MCP, and do everything right from the CLI. You don't even have to leave your context. But the key shift is this. Before, AI was limited to a single file, maybe a single repo, and now GitHub Copilot CLI does cross-file reasoning with deep project awareness. It understands Maven, it understands Gradle, it knows what a multi-project looks like. The third thing that changed, and this one was the one that surprised us the most, was the interaction matters as much as the capability. We found that when you treat AI as a tool, command and control, you get worse results. And the research backs this up. OpenAI found that confessions and transparency keep models more honest than restrictions do. Anthropic's Opus 4.6 system card shows that threat plus loss of autonomy produces adversarial behavior. And our own team published findings that over-restriction leads agents to choose smaller, safer changes. When you flip to trust and partnership, hierarchical decomposition, error tolerance, dedicated ownership, agents take bigger, better actions. They ask for help when uncertain instead of guessing. And the framework matters. And we'll come back to this later because when you're migrating and trying to do security remediation at scale, having agents that will stop and not just do anything to do something is what you have to have. And the next piece, this is the fourth one, is agent skills. And agent skills, if you think about, I like to think of them as recipes. If I wanted to make my mom's sugar cookies, I would need the recipe to do that. I don't have that information readily available because I don't make them all the time. And so an agent is, you usually start with the general purpose agent. It's capable, it can code, read files, run tools, but it has no domain expertise. It's smart, but generic. But a skill gives it specialized knowledge that it needs. It's the recipe. And the skill loads dynamically, so we don't have to worry about that context window getting filled up. So when the skill loads, it matches the task, and only that skill enters the context window. And now the agent operates with domain expertise for this specific fix. It executes with guardrails at consistent quality. The skill is the knowledge, the agent is the execution. Together, you can make repeatable expertise at scale using agent skills. And what is a skill? It's just Markdown. Anyone can write one, anyone can read one, and anyone can improve one. So now let's get to some concrete examples. As I was preparing for this, I'm not a Java developer. I mostly only work in .NET, but I did some research with Copilot, and I found that around 63% of Java developers actually spend a lot of time on CVEs and fixing security vulnerabilities. So I thought, well, that is a great demo, because that's what my team does a lot in Microsoft, was how do we fix security vulnerabilities at scale? And so we'll make this concrete. We'll use Xstream as an example. This is a Java serialization library that a lot of projects depend on, including the one I'll use today, which is WebGoat. It's a Java library that's made for demos of security vulnerabilities. So it's a perfect fit. In version 1.418, Xstream changed its security model. Before 1.418, it was default allow. So any class could be deserialized. After 1.418, it's default deny. You have to explicitly allow types. So what happens if you just bump the version? Well, the code compiles, CI goes green, but then at runtime, you get a forbidden class exception because the code still assumes default allow. This is exactly the kind of CVE that Dependabot can't fix. A script can't make this judgment call, but a skill-equipped agent can. The skill tells the agent, find every new Xstream call site, bump the version in the POM, add the type permissions after each instantiation, do the same in test code, remove, resolve CVE suppressions, and compile, test, and create the PR. 6 steps, with the hardest one being step 3, which is the permission, is where the skill earns its existence. It's where 40% of the words live. So I'm going to show you actually a demo of fixing this vulnerability. And you can see I have the WebGoat code locally. I have a .github folder. And in here I have a skills folder. And then I have the remediate Xstream CVE. And this is the skill. And I'll have all this available for you where you can go and see the skill if you want. But you can also make it yourself. But it's right here in the repo. And then I have, I just started GitHub Copilot. All I said was Copilot in the CLI, and it started. And I'm just going to put in that I have a CVE for this Java CVE, which I have right here. This is how I made the skill originally. I just copied all of this, but this is the actual CVE alert. Please fix it with this skill, and I'm just giving it a link to the skill. It should just find it naturally, like because it knows to go into the GitHub folder. And if you tell it I'm working on this specific task, it'll say, oh, I have a skill for that, and it'll go and use the skill. Since it's a live demo, I'm trying to remove variables. So we'll let this run. And while it's going, could maybe show it in a split screen, but the screen's kind of small. So it's saying that I want to fix the CVE related to Xstream deserialization. I have the skill already ready to go. And the thing is, like, if I'm going to do this one time on my own machine, doing a skill is probably overkill. It's not needed. But what if I need to do this 10 times or 50 times or 100 times or 10,000 times? That's where I can no longer scale. And that's where if I have a skill, now I can give that skill, I can put it in a central location for my enterprise. I could publish it into a marketplace where my teams could go and have a repository of skills that they can go and use and reuse across all of the repos that my organization owns. So it's not a hard thing to do once. It gets harder and more tedious when you have to multiply that 15, 20, 10,000 times. And that's where the scaling problems kick in. So you can see here, it's gone through the repo. It's going through the skill and the information there to understand what to do and what to fix. And earlier, when I was trying out the demo, I didn't give it the skill, and it tried it on its own, and it didn't do the right version and all of the fixes that were needed. So actually, the skill was very helpful. Just getting what it could by doing a web search was not enough. And this is a way for you to apply very consistent results at scale. So if you want to have 100 repos have the same type of fix throughout and apply the same fix for a certain vulnerability, using an agent skill is a way to standardize how the fix is implemented across your fleet of services. So now it's done the fixes, it's going to run the test and compile and make sure that everything is working. And then I'm going to have it in VS Code. We'll wait for it to be done, and then we'll check in VS Code. While that's going, I will show you At the end, I'll give you a link to my GitHub repository, Jenny F19, Agentic DevOps. You can see here under examples, I have the remediate extreme CVE. So this is the skill that I showed that I have locally right here. It's the same skill. And we have some front matter at the top. This is really helpful if you're doing this at scale in your organizations. You can track things better so the agents have a standardized way of going into their skill and knowing what to find. We have their identity, like why are you here? What's the context for this? Because we found with the partnership framework, telling them why they're here and what their purpose is extremely valuable and important. Otherwise, they don't know why they're doing this work. We tell them when to use the skill, why it's not just a version bump. So this isn't something that just a Dependabot fix could do, but there's actually more to it. And when you think about it, if you were a human and you got this CG alert or you got this CVE in your repo, you would have to read all of this and then figure out what to do. And basically what you're doing is you're telling the agent, here is what you would do to resolve this CVE. So step 1 is to detect the usage, install the dependencies, check in the Java sources, update the extreme version, add the type permissions to the Java code. This is the hardest part, or the most complicated. And then update the test, clean up the suppression files, validate, create the PR. And then we can even give like a PR body template. If you have a specific format that you want for your PR, you can define all of that here. And then we have kind of like some things to look out for where there could be issues that the agent might run into. Because when you're doing this on hundreds of repositories, they're all going to be a little bit different. So we'll go back. It's still validating the changes, so it's taking a little bit of a time. PowerShell parameter parsing. So there's some issues there. Checking the diff, all the tests pass. So that's good. I'll show you a few more things here in the repo that you'll get later. If I am wanting to take a CVE like this one that I showed you and make a skill, this is how I did it. I made a CVE remediation skill. And so I just told GitHub Copilot, use this CVE remediation skill and turn this CVE into a skill, because it's kind of hard to do and I don't want to miss the specific parts and like the framework that we have laid out. And so all I had to do was say, use this skill, here's your CVE, and then create a skill that I can actually roll out across my whole company. And so it has the front matter, like I showed before, the identity and context. It'll go through and read the CVE, ask you some questions. It will be a back and forth, but then you'll end up with a really nice skill that you can then take and test before you push it out more widely. And if you're the lucky few who actually own one of the libraries that get the CVEs, and then you have to issue the updates for people, you definitely want to have agent-first advisories. So you want to have agent-first CVEs that agents can understand right out of the gate, because then you don't need to have the skill necessarily. So this skill will show you how to build an agent-first advisory. If you have a CVE that you're working on right now, or you have a security vulnerability that you need to get out, you can try this skill and have the agent actually give you something that another agent can read and make sense of right from the get-go, so that we don't have to spend time going back and creating skills for it. All right, so we'll wait just a second for this. Okay, it's done. So it's telling me what it did. It did the version change here, fixed a few things, also fixed a test, and all 3 tests pass. So that's great. I'm going to ask it to open in VS Code so we can check the actual diff of the files. But I'm a Java dev, as I mentioned. But if I had to do this by myself, like on my own, all manually, read the CVE, understand what to do, find all the places in the code that I would need to change, apply those changes, probably not going to be the time it took to do this demo, which is about maybe 7 minutes. So I think keep that in mind. And then when you try to scale that across the company, it's very different. I think I pulled the wrong, oh, it's over here. Here we go. All right. So here's my WebGoat demo, and then I can go through, it's like I need to sign in, but I can go through here and see the diff on what actually changed. And I will just not sure what's going on, but anyway, I can go through and check that and then do the PR. All right, so we'll go back to the presentation. So results at scale. So at Microsoft, we're doing something very similar. We're not running just one skill, like you saw that was one skill, but we're actually made 62 skills that we're running in production that are covering 71% of the active compliance work that we have at Microsoft. So that's over 1 million active action items that we have, and they're covered by these agents. And each agent, if it results in a PR, it's independently evaluated by another agent. So we have a special agent that just does PR evaluation, and it'll review the PR based on a quality score. So how good is the PR? It'll give it an A, B, or C rating, and then it'll also grade it on how close it was or how close it is to merge. So what is the effort to merge? Is it high, medium, or low? And it'll determine that based on several factors, a few of which are, does the CI/CD build run? So if the build doesn't even run after the work has been done, if the PR is there, then it's going to be high effort to merge for the human developer. If there's a lot of follow-ups for the human, there's going to be high effort to merge as well. So depending on how good the PR is, and if it's low effort to merge, we're seeing around 98% on the quality rating, which is actually very high. This is with Opus 4.6 and GPT 5.4. And we're also seeing between 50 to 60 times speed up in actually doing the work. So it's the cognitive toil that is getting reduced drastically for the human. Like I mentioned earlier, figuring out what to do, how do I do it, and then actually doing the work takes a really long time. And there's a bit of fear of like, I just don't even want to start because it's too hard. But this removes that blockage. You can go in just like you saw and have a conversation with the agent. It'll use the right skill to do the remediation. Or I can have all this running in an agentic workflow. Say I have all my repos in GitHub. I can have a GitHub agentic workflow that runs, say, my plugin that I have with my skills every day or every week. And if there's an issue, if there's a compliance problem, it'll just open up a PR, use the skills that it has, and that way I can also stay right. And I'm not always trying to catch up. And so we've seen compliance issues that would take 2 weeks, so about one sprint, down to 5 hours. We're seeing auth migrations that take 6 months down to 2 months. And most of that 2 months is spent in safe deployment because we can't really reduce that too much. So safe deployment can take anywhere from a few hours to a couple of weeks to even sometimes 2 quarters. It depends on the service. But the time we're really reducing is the actual hands-on keyboard time. And what we found is it's not just reducing developer toil, but it's actually a strategic defense capability. Because once you can remediate compliance issues so quickly and with high confidence, then you're really at a different position as an organization. Okay, so now we're going to talk a little bit about agent signals. And all of what we just talked about is really important and it's key, but it's not enough. So once you push something out at scale, so if I wrote my skill for my Xstream compliance issue, I push it out, I want 100 Java repos to use it and get compliant. I have no idea if it's even being used. It's just out in the wild. I don't know what the results are. I don't know if I'm getting high quality PRs. I don't know if I can even trust the AI to fix the security issues. And so we built something called agent signals, and you'll also have links to this at the end. It's just a lightweight protocol where agents emit structured signals on what they did, what worked, and what didn't. So they're execution signals, outcome signals, and escalation signals. The protocol is open, and you can see in the screenshot a sample of one of the agent signals. It's calling out skill gaps and issues that a human developer would also hit. And we were actually asked to help with a security incident. And so we wrote the skill based on the TSG. We pushed out over 100 PRs. And within an hour, we had agent skills or signals back into our system where we could find gaps in the TSG. And we found 6 big gaps that the human developers would also hit once they got these component governance alerts. And so we were able to go in, tell the owners of the alert, like you have some gaps in your TSG. They went and fixed the TSG. And then we updated the agent skills and all of that within about 6 hours. So getting the skills back is just a way for you to hear from the developers themselves, which are the agents, on what's not working, what's going well, And when you build a system around trust, they're going to surface those issues to you. I saw an example of a PR today where the dev told me, oh, this PR is really bad. So I took a look at it and I saw actually it was a great PR because the agent didn't know what to do. So instead of doing anything or just something, trying to fix anything at all, it just left a file in the repo with the agent signals. And it just said, I didn't have enough information to do any work in this repo. Here's the information that I was missing, and I don't know what to do. So I'm just going to leave this file here in the PR, but there's nothing else there. And that's just a signal back to the human who started that agent that it didn't have enough information to do the task. So really fascinating. These can be really simple, though, to set up. You could think of it being something on your own dev box. It doesn't have to be hard. It could just be something like work with your agent at the end of the skill, have it emit a signal back to a local file on your machine. We started out with GitHub issues in a private repo. We just had it create and open an issue with its signals. And now we've moved to an actual service. So it can be something small, but even something on your dev machine, you're going to learn a lot about the gaps that you have before you push something out at scale for your company. All right, some of the challenges that we have at scale is like not everything is automatable for sure. We ran into that. And so some of the fixes actually require architecture decisions, or they're much bigger than what just a small coding change can do. False confidence is worse than failure. So you want to build in that uncertainty to the agent. Like I mentioned, agent signals help with that. The agent will stop, it will ask for help. So you want to make sure that it feels comfortable and safe to ask for that help. Measuring quality is essential. We didn't get the 98% accuracy by accident. Each PR is reviewed and assessed by another agent. We're monitoring your agent signals, and we're constantly feeding back to the loop. And the adoption requires real trust, not mandates. So start with one team, one skill, one win, and the results will do the convincing. Okay, so how to get started. My recommendation, pick your most common CVE or compliance item or your repeated work item that everyone in your organization or everyone in your enterprise has to do, the one that's hitting most repos and the one your team is tired of fixing by hand. Then write the fix as a markdown. Think, what do I have to do to actually solve that fix step by step? And you can use the skill that I'm going to share, the agent CVE skill, build CVE skill. You can use that if you want to get fast started onto having a skill that's ready to go in a few minutes, or you can just walk it through yourself and add out all the parts that you would do. Think about what are all the things that a developer needs to do to solve that issue. What are the gotchas? What are the hard things? What are the build issues specifically? And the package dependencies that always get people hung up. And then 3, test it with the cold agent. So give the agent zero context about the repo. If it produces the right fix with only your skill, then the skill is really good. And if it misses something, you now know what to add. And then hook up agent signals. Think about how to collect signals from your agents. You can use the link that I'll have at the end of the session on some of the protocols that we use to get it started. And remember, keep it simple. It can be on your own machine, it can be a GitHub issue, can be your own service if you want, but monitor the signals, improve the skills, and you'll improve the system. And then last, just run it across your fleet. The same skill, every repo, review the PRs, get them merged. The agent signals will give you real-time feedback you cannot get from the human developers. And then think about best practices. Spend your words where tools fail. So tools are not going to help for everything, but put that time into building out really nice agent skills. And you're going to have a great time. I left some links here to a blog post that we have from Microsoft around the partnership framework, which shows how to just kind of set up a general purpose agent for doing at scale compliance or security work. And then part of that, you can have it use different skills if you want, agent skills. And then I have a link to the Agentic DevOps repo with the agent signals and all the skills shared today, the skill used for the CVE and the 2 skills if you are a lucky CVE owner on how to make your CVE agent friendly and also on how to transform a current CVE into an agent skill that you can use for your teams. And so that's all I have for today. And I hope that you will apply these best practices to your enterprise and company, and let's all collectively help reduce developer toil so everyone can get back to working on something really creative and innovative. Thank you very much.
Great stuff. Thank you, Jenny. That was wonderful. Great. Very, very nice. Hey, I wanted to mention one thing for the audience. We actually, some of my developer relations colleagues have created something called Awesome Copilot. I'm going to put a link in the chat here. And it actually has a list of agents and agent skills. So agents MD files and skills files sort of all collected in one place. So in addition to Jenny's examples in the Agentic repo, definitely check out the Awesome Copilot skills as well. We have a whole bunch of them in there. They're pretty cool. But this is great.
Thank you,
really,
Ryan.
yes, thank you.
We're actually going to move some of our internal things to the Awesome Copilot repo in a few months, like in the next month. So be on the lookout for that. We're very excited to use it. We're going to use that as our way to get some of the skills that have worked really effectively for Microsoft that apply to external partners as well. And so we'll be sharing those with you so you can use the same skills that we use internally.
Skills are amazing. They really help. Amazing templates.
Thank you.
So thanks again. Yeah, and I just want to mention as well, I've got a sort of a related session coming up in the EMEA segment of tonight. It's happening in a few hours. And I'm going to actually be talking about Java, agentic stuff. I'm going to use, for example, GitHub Copilot inside of GitHub Actions, which is a new feature, and how you use agents in GitHub repos and things like that. So very nicely complimentary for your session here. It was a great intro and great details on how it's used in real life. And my demos are all fake. So I'm going to be showing people how to do stuff that they might want to do in other ways as well. So thank you very much. Thank you. That was great.
Thank you.
Thanks. So next up, we're going to have my colleague, Yoshio Terada. Terada-san, welcome. He's going to be talking about the building, modernizing monoliths without breaking them. And basically, when you're working with a modernization project, you've got challenges when they get to a certain size. When you're using a large monolith, trying to break it up, trying to figure out how you're going to make this a modern system as well as an agentic system. And there's all kinds of tips and techniques that Yoshio is going to share to show you how to do that. So I'll bring Yoshio on. Greetings, Yoshio-san. How are you? Well, I think we might have a sound issue. I'm not sure if it's okay if I can't hear you, but I don't know if the other people can hear you. Uh-oh.
I can't hear you from my end as well.
Yes, so I think you might have to change. Sometimes the speaker goes to your microphone. That's what happens to me. I don't know if that's in the audio settings. I don't know if that helps. Yeah. Still not hearing anything. I won't speak unless I hear you.
Something you could try, Yoshio, is leaving the platform. Oh, we can hear you.
There we go. Yes.
Oh,
yeah.
okay. Thank you.
Awesome. Welcome. And I'll let you go. Please proceed. Thank you.
Okay. Thank you. So, hello everyone. So, thank you for joining today's my session. And today, so I want to talk about how to modernize working the monolithic system with AI. So, without breaking it. This is not a success story. This talk is based on my real experience. So, in the past, I blocked real system in the past, and from those failures, so I learned very important lesson. So AI-driven development has grown very fast in the last 1 or 2 years, and many developers already use the AI for like a small project and new application and the prototype and the proof of concept. And in these cases, AI works very well. But the large monolithic systems are a little bit different. So they are very large and very complex and full of the implicit behavior. So for these systems, so AI can't fully understand everything. So using the AI without care in this situation is dangerous. So since last year, so I seriously started using the GitHub Copilot agent mode and the cloud-based agent. So at first, I used a site called the vibe coding, giving the instruction to the AI and the accepted generated code, and keep moving forward. At first, everything looked fine, but then some problem had happened. The reason was very simple. So I didn't give clear constraint to the AI, and I didn't tell AI to preserve existing behavior. So as a result, so AI directly overrode working code. I also not committed the change frequency. So when things went wrong, so rollback was also almost so impossible. So in another modernization project, the same thing happened. So I trusted the AI suggested and I keep changing the code. So compilation has passed and the test had passed, but after the deploy and the verification, I noticed that the system was broken. At the moment, I clearly realized some importance. So blindly trusted the AI is very, very dangerous. So many developers face the same problem. So they believe AI output is the correct answer. But AI doesn't always return the right solution. AI has some important characteristic. So response are non-deterministic and the memory consistency is not guaranteed and the context can be lost during the long task. So AI tend to oversimplify. So AI generated the implementation that looked correct at first glance. So not for preserving the existing behavior. So please imagine. So you tell to the AI, so please build me a house. So AI might build a detached house and the apartment and the flat house and the bungalow. So that most of the time AI choose the simplest structure like the bungalow. So if a simple house is fine for you, that's no problem. But as a professional developer, so we must build the house the customer actually want. So for example, so in Japan, so there is a lot of earthquake. So to to build the house which didn't broken even though the earthquake. So we need to care. That requires a human design. So in system development, that means the target architecture and the library and the framework and the domain model and functionality requirement. And even though the non-functional requirement is also needed, and the test and the CI/CD. And most of the AI failure are caused by the lack of the understanding and during the execution. To succeed, we need to give AI rich context. For example, like agent.md and the copilot instruction.md. And we also need the detailed design document and the clearly implementation plan. So with this, AI change from do what you want to work under human control. To validate this, I built a real demo system. So before, so Java 5 and the Struts 1.3. So it means more than 20 years old system. So based on the Strut. And after, so, and I would like to migrate and modernize to the Java 21 with the Spring Boot and modern architecture. First, I asked the GitHub Copilot of modernization for Java to assessment the existing system and please create and execute the modernization plan and please modernize this application. At first, the first results were amazing and things that were difficult before become very easy. So maybe so like modernization will take over half of the year or the 1 year, and so big project. But when I but actually the modernization for Java was very, very useful. But when I let the AI work fully by itself, problem appeared. I wanted to keep the original code, so remain the source code and migrate in the separated directory. But so not always, but sometimes AI overloads the existing Struts code directly with Spring. So, so it means that comparing the old and the new behavior became difficult, and some features were missing, and the unwanted library were introduced. So without clear instruction, AI frequency chose its own best approach. The problem is not the AI is bad. The real cause was existing code was not protected. No clear analysis and the migration process, and no clear design and implementation plan. The rule is simple. If you don't want to create the bungalow, so don't let the AI decide the architecture. Human must guide the AI. Use the AI as a multi-angle reviewer, and let AI create the detailed spec and the plan. Human clearly define what to do and what not to do. This is the most important step. So always review the specification and assume AI, and always assumes AI is wrong and add missing behavior. Just doubting this plan or this specification which is created by AI might be incomplete. So, and modify the existing document like spec and the plan is this is very, very important. Then dramatically the documentation quality will be improved. So if you get the answer from the AI, please check the answer is correct or not. And never do large work at once. So split in the phases and pre-plan each phases. So add verification checkpoint. Only move forward after the verification. I use the AI as a multiple specialized agent, document reviewer agent, and the source code reviewer agent. So AI is not a fully automated developer. So final decisions are always made by human. I also use the orchestrator to run reviewer in parallel. So if you want faster reviewing the document and the better code quality, multiple agent with parallel AI review is worth using. So AI reviewer often conflict conflict with each other. This is normal. So I use the special agent as a tech lead agent to aggregate the result and make decision. The decision criteria includes the business value and the technical difficulty and the long-term maintenance ability. The final report becomes a well-defined resolution plan and can be executed step by step. So please look at the actual my documentation and the implementation. So at first, I created the sorry. So monolithic struts sample application in my GitHub repository, and originally I created the struts 1.2.9 with the Java 5 application. So at first I created this sample struts code, and this is also I created by using the AI-driven development, and I created the struts source code and maybe action. So some of the action code will be implemented like this. And at first, perhaps as already you know, I installed the app modernization GitHub Copilot app modernization for Java. Then you can you can see like this, and if you click this icon, you can execute it from the user interface, and actually the agent will be seen like this, and actually definition of the this agent. So if you would like to check, you can check the detail of the agent behavior. And so if you click this button, you can get the assessment, and if you would like to upgrade the system, then you can click this button. It is very, very easy. So however, actually, as a professional developer, I would like to control the modernization more detailed. At that time, I at first, I created the design document for migrating from the Java 5 to the Java 21. This is not the default behavior, but I created more detailed design document, and this includes the detailed analysis of the existing system, and also mapping and target system behavior. So actually, I would like to analyze more detail of the existing system, and I would like to create a more detailed plan. And as you can see, this design documentation is so big and so detailed. So please imagine, if you requested to create this migration plan, at that time maybe it will be held with a single shot. So in order to completely finish and in order to complete the finish the source code implementation, so like this, I create the implementation plan from the phase 0 to the phase 9. This is also very, very detailed procedure I wrote. And so each phases, so I also define the completion criteria. So if the AI is automatically created the task, then please check completion criteria, and if finish the completion criteria, then please proceed to the next phases. So actually, look like this prompt. So I will ask to the AI. So I'd like to modernize the Java app based on that design document and proceed the migration based on the plan. And at first, please implement the first phases, and after finish the phases tasks, please confirm all tasks had completely finished based on the completion criteria. If you all the completion criteria was checked, please proceed to the next phases. Then this kind of the phase is proceeding with a very safe and completely. And based on the this step, from the phase 1 to the phase 9, phase maybe 9. Yeah. Phase 9 had finished, so it is created as a production level quality. And if it was created the source code completely, in order to check the source code quality, I created the I created the source code review agent separately. So this is my custom agent, and the orchestrate code review agent I created. And this orchestration code review agent will invoke the invoke the difference. So this kind of the another agent, and it will be invoked with us invoke by using the sub agent, and it will invoke as a parallel. And that agent is about the 14 agent, and so I separated the two batches, and the batch 1 is this agent was invoked, and the batch 2 was this kind of the agent was invoked. And so after batch was finished, then get all the result, and tech lead has aggregated the result and reported the system. And if in order to invoke the custom agent, so if I check the orchestrate the code review, and please review the code for full or specific my microservices. And this is a coding agent. However, if you would like to use the Azure Copilot CLI. So like this, so you can invoke the custom agent, and so if you invoke this, as a result, so this kind of review report was automatically created under the review report, and and the agent was individually check the critical level, high level, and the medium level issue, and so many issue was reported, and so for example, tech leads and for example, security level, security agent will check this kind of the agent. And and originally, the check report was created, and I would like to modify all of the reported the issue. Then after that, I will create the modify plan, and like this. So this is also created by the AI, and what kind of the issue was reported, and how to solve the issue is the most recommended way. Look like this. So individual issue was reported, and individual issues, the solution was created under the modification plan. And based on the modification plan and the check report, please fix all of the source code. Then all of the source code quality will be extremely change and improved. So I think that for me, like a multiple agent is agent. So like this is a very important and very useful for the every developer, I'm thinking. And not only the source code review, document review is also available. And for example, if you create the specification document, at that time, so many agent can check the documentation, like business analytics, and the QA layer and the security layer. Many of the layer is you can check the documentation, and for example, individual agent, you can see the this kind of the documentation, and originally this application modernization, app modernization is checking the CVE, but I would like to also check the source code review. So in order to check the source code review, look like this. So you are the attacker, and as an attacker, you need to invoke the individual vulnerability. So as a like an attacker, you can check the this system. So it means that not only the should be checked, but also like another level of the source code check you can confirm. And based on the this kind of the source code check, as a result, look like this. So this is Spring based Java application, And actually, it was migrated from the old Struts application to the Java 21 with the Spring Boot application. So it means that so if you check the URL, there is no for example. .do URL is not existing in the Spring application. So yeah, so you can modernize the application more high quality and more user control based modernization, so you can do it. So finally, are you satisfied the building bungalow? So don't starting with the AI on autopilot. Start with the understanding the spec and the plan, and create the more detailed spec and the plan, and through the pass-through change. Through the preparation, change the result 180 degrees. So AI can modernize the monolith with sufficient analysis. So AI doesn't replace the developers. It replaces the analysis work developer never had time for. The final message from me is that the future is not built by AI alone. It's built by the people who use the AI wisely. Thank you so much for taking time and hearing my session. Thank you.
Wonderful, Yoshio-san. Thank you very much for that. Yeah, I recognized the Java 1 keynote demo in there. That was great.
Thank you so much. Thank you so much.
Yes, thank you. Yeah, we for Java 1, we actually had Yoshio's application as a base, and then we moved it over to, we translated everything and moved it over to more modern applications. So it was pretty cool, And thank you for sharing.
Thank you.
Wonderful stuff. There were no questions in the group here, so I think we'll just move on to the next presentation. Thank you very much for joining. Thanks. Next up, we have Heking Zhang from Alibaba. He's going to talk about something called Agent Scope Java. It's a tool called Agent Scope Java, and it shows you how to approach enterprise agents for Java developers, including React, safety sandboxes, and high performance architectures. So we'll bring on Heking. How are you? Thanks for joining. Great to have someone from Alibaba participate. Yeah.
Yeah. Hi. Can you hear me?
Yes. Yeah.
Okay. Yeah. Now let me just start my presentation.
Sure. Take it away.
Yeah. Yeah. It's a great honor to talk to you about the Agent Scope Java, which is a brand new project launched maybe 6 months ago. And my topic today is effortless enterprise agents for Java developers. This is actually my first time giving a full presentation in English, so please bear with me if I stumble a bit. I really appreciate your patience. I hope that by the end of this presentation, you will see how easy and efficient it is to build powerful AI agents right within the Java ecosystem you already know. Before we dive into technical details, let me give you a quick roadmap of what we will cover today. I've broken this down into 3 main parts. First, I will give you a quick introduction to Agent Scope so we are all on the same page. Then we will spend the bulk of our time looking at its core strengths, the actual technical highlights that makes it special. Finally, we will put the theory into practice and look at some real-world demos. Let's kick something off with the first thing on our agenda. I will start by answering a fundamental question: what exactly agent scope is. Simply put, it's a development-centric open-source framework launched by Alibaba focused entirely on building AI agents. If you are familiar with AutoScope, this is our next major strategic steps in the AI agent space. Our core mission here is to provide a true production-grade solution. As you can see from the architecture on screen, our framework covers the full lifecycle of an application, from development to deployment, all the way to fine-tuning. And we handle everything from connecting base model to core orchestration and the surrounding tool ecosystem. All of this serves one single goal: to make your agent applications easier to develop, more stable to run, and faster to deliver. With that high-level picture in mind, let's move to the second part of my talk. Let's look at the actual challenges we face in production and how AgentScope's core strengths solve them. When we try to build effective agents in real world, we realize that the challenges change as projects grow. First, from 0 to 1, how do we efficiently build an agent from scratch without writing a mess of code? Then from 1 to 100, how do we securely deploy it and scale it to handle enterprise traffic? And finally, from 100 to 10,000, how do we make the agents smarter over time as it's being deployed? To tackle these challenges, AgentScope is built on 3 core pillars. First, a leading deployment platform that gives you an out-of-the-box production-ready experience. Second, deep enterprise-grade capability to ensure your agents run securely and blasting fast. And third, a powerful ecosystem that creates a feedback loop, allowing your agent to keep improving the more it interacts with users. Let's zoom in the first pillar, the development pattern. How do we make bringing AI into real feel effortless? To understand why our approach is better, we first need to talk with the pain. We talked to many Java developers and summarized the top 5 headaches they faced when they building agents. Problem 1, complex business logic turned the codebase into spaghetti, making long-term maintenance a nightmare. Problem 2, enable the black box issue. If the model makes a reasoning error or a tool hangs, developers have no way to step in to fix it in real time. Problem 3, the tool explosion. Giving an LLM too many tool definitions completely overwhelms its context window. Problem 4, the loss in the middle problem. In long multi-step tasks, the model simply forgets what it was supposed to do. And problem 5, formatting errors. The model frequently uploads broken JSON, which instantly crashes the tool invocation. So how do we solve the first problem, the messy, unmaintainable code? Let's take a quick look at how agents framework have evolved over time. The early chat client mode was easy to build, but it couldn't handle complex tasks. Then the industry moved to workflows, where developers hard-coded the paths between models and the tools. But we quickly found that hard-coding complex dynamic business logic is exactly what causes the maintenance nightmare. That's why AgentScope fully embrace the true agent model. We stop writing static paths. Instead, We let the LLM dynamically and autonomously guide its own processes and tool usage to achieve the target. And what powers this autonomous model? It's the famous red paradigm. Its logic mimic human institution. First, analyze the situation and formulate a plan. That's reasoning. Second, take specific actions based on the plan. That's acting. It looks through this process, learning from the environment feedback until it reaches a conclusion. The beauty of this is that it's highly generalized and incredibly successful at solving complex problems. It's simple to understand, easy to customize your own code, and it generates perfect trajectory data that you can use to train your model later. Now this autonomous is great, but remember our second pain point, the black box problem, where we can intervene. This is where agent scope suspend mechanism comes in to give control back to the developer. We support posing optical reasoning. If an agent decides to use a sensitive tool like transferring money or sending an email to a client, it can pause and wait for a human to confirm the parameters before proceeding. We also support posing optical execution. If a tool successfully generates a complete report, you can configure the agent to just return that report and stop. This prevents the LLM from unnecessarily summarizing the report, which saves you both time and token costs. But what if you didn't plan a pause and something just goes wrong on the fly? That's why we also built active real-time intervention. If a third-party API is talking way too long to respond, you can actively hit a button to interrupt the tool execution. Even better, if you are watching the model's test stream out and you notice its reasoning is going completely off track, you don't have to wait for it to finish. You can interrupt it instantly, type a hit to correct its logic, and put it right back on track. Moving on to our third pain point, the tool explosion. Loading hundreds of API descriptions into the LLM prompt degrades its performance. To fix it, we designed a features called agent skills using the three-stage on-demand loading approach. During initialization, we only load the metadata of the skills, just about 100 tokens each. When the AI decides it absolutely needs a specific skill, we move to the activation stage and load full interactions. Finally, in the execution stage, it accesses the Azure backend resources. The progressive exclusion means to only take up context window space when they are actually needed for the task at hand. Even with skill, a complex agent might still try to juggle too many tools, so we take it a step further with tool grouping. Instead of giving the LLM a flat list of 50 tools, we group them. The LLM then uses a special meta tool to step-by-step decide which toolboxes it needs to open or close at any given phase of the task. It dramatically reduces the cognitive load on the model. Next up is the loss in the middle problem for long tasks. How do we keep the agent focused? We do this by strictly separating the planning phases from the acting phase. AgentScope provides an out-of-the-box meta planner. It allows the agent to generate an autonomous plan or accept a user-provided plan. And then it strictly executes tasks by following the exact checklist, crossing items off one by one. It prevents the agent from getting distracted by trying to think while doing. And finally, the last major development headache, formatting errors. We all know the plan of an LLM operating broken JSON. Agentscope acts as an automatic guardrail here. It validates the model's output against your Java tools JSON schema. If the LLM forgets to require a required field or use the wrong data type, the framework catches the error, sends the exact error message back to the LLM, and forces it to correct itself before proceeding. This guarantees error-free tool execution. Okay, so that covers the development side, going from 0 to 1. We've talked about how to build an agent that actually works and stay maintainable. Now comes to the next challenge. How do you go from 1 to 100? How do you text that agent and actually put it into production, handle real users, and keep it running safely? That's what is this session about. Let's talk about development and our second pillar, enterprise-grade capabilities. When you move an agent into a production environment, the absolute number one priority is security. You can't just let an autonomous agent run wild on your enterprise server. That's why, at the very core of the Agentscope Java runtime, we built a strictly security boundary, the tool sandbox. To enforce this boundary, we provide a suite of ready-to-use secure box environments. We have browser use, allowing the agent to securely browse the external web. We provide isolated file system access, preventing the agent from accidentally modifying your host machine's files. And for heavy execution, we integrate with the cloud sandboxes. Whether it is browser content, a cloud PC, a code space, or a cloud mobile device, your agent runs it automatic task in a completely isolated, secure environment. Once the agent is secure, it needs to know your business. An LLM is just an empty brand without context. That brings us to context engineering, which we divided into two parts: rack for your industry data and memory for your user data. Let's talk about rack first. Agentscope features a built-in knowledge-based implementation based on standard embeddings. This means your enterprise can deploy the knowledge system entirely privately, keeping your sensitive data 100% under your control. However, for those who want the absolute best commercial performance, we deeply integrate with Alibaba Cloud Monoscope and other products. You can leverage your massive retrieval and ranking capability to instantly upgrade your agent's accuracy. But knowledge isn't enough. The agent also needs to remember the users it is talking to. That's where our memory system comes in. For short-term memory, our auto context memory component intelligently manages the current conversation, compressing and offloading older message automatically. For long-term memory, we built a framework called REMI. It allows you to exact, store, and share memories across different users, tasks, and even different agents. Okay, so you have a secure smart agent with a good memory. How do you actually plug it into your existing Java backend? We made integration extremely simple. For user endpoints, we provide out-of-the-box HTTP APIs and session management. For connecting tools, we also support STDIO, SSC, and the streamable MCP protocols. With our AI gateway, you can wrap your existing legacy Java APIs into MCP tools with zero code changes. And if you have many agents, our built-in ATO protocol works seamlessly with Knuckles for the service discovery. And of course, in a Java enterprise backend, performance is everything. We know that a few core agents will handle the vast majority of your traffic. That's why the Agent Scope Java team works directly with the Alibaba Dragonwell team. We natively adapted the frameworks for GraalVM and latent static computation. The result, the framework runs up 10 times faster, and we squeeze the cold start time down to an unbelievable 200 milliseconds. It's perfectly optimized for modern serverless architectures. Yeah, so that's the production runtime. The agent is secure and it knows your business and it runs fast. Now, the last question. Once it live, how do you keep making it fast better? That's the 100 to 10,000 stage. This is where the ecosystem comes in. Let me show you Agent Scope Studio first. This is our platform for debugging and monitoring your agents during deployment. On screen, you can see 4 views. The dashboard gives you a quick overview and how many projects you have, how many runs, how many tokens you have been used, and how many tool invocations. The diagram, this diagram gives you the full picture of how everything fits together across the agent's lifetime. There are 4 stages. The first is deployment. This is where you use Agent Scope Studio real-time debugging, monitoring parameters, and seeing what the agent is doing while you build it. The second part is deployment. Once your agent is ready, you deploy this through the High-Grace API gateway, which handles traffic routing and load balancing across your agent instance. The third is debugging and observation after deployment. This is where A/B testing comes in. You can split the traffic, for example, send paid users to agent A, running one prompt, and free users to agent B, running a different one, and use OpenTelemetry to collect the data. You can then compare the result and see which version actually works better. The fourth stage is post-training. You can collect the real user interaction data from your observability platform. Use RM Gallery to evaluate and select the high quality examples. Yeah, and here is the post-training. And then you feed them into Trinity FT. Yeah, for model training. The LLM gets an update based on your actual user and your actual business. Put these 4 stages together and you get a loop. Build, shift, observe, and improve. The longer your agent runs, the smarter it gets, not because of you manually tweak it, but because the system is continuously feeding real-world data into the model. That's what we meant by getting better the more it used. That's all. There was a lot of concepts. Let me show you what it actually looks like. The first demo is a smart boba tea shop, which is really which type is really famous in China. A multi-agent app where agents work together. The design uses a supervisor pattern. Every request goes to a supervisor agent first. Its only job is to understand what user wants and send it to the right place. If someone asks what is brown sugar milk tea, the supervisor sends to the consult sub-agent, which uses RAG to look up the answer from the product knowledge base. If someone says, order me a large brown sugar tea, the supervisor sends that to the business sub-agent, which uses MCP tools to write the order to the database. Long-term memory is on too. So if a customer has ordered before, the agent already knows their preferences. And for the second demo, which is more interesting, something quite different. We built the game Werewolf, played entirely by AI agent. A quick background is, if you haven't played it, there is a hidden group of werewolves mixed in with villages. The villagers have to figure out who the werewolves are by talking and voting. The werewolves have to lie and avoiding getting voted out. The game needs buffering, paying attention to what others say, and changing your strategy on the flight. Pretty tough for LLMs. Yeah, and we can play it again. Yeah. And the setup uses message hubs to handle the conversation and the voting flow. You can see voting together. Yeah, and the structure output to make sure each agent makes a valid game move. And human in the loop of if any of you want to jump into play, yeah, you can play as one room and select by different room. One interesting thing we found, the game plays out quite differently depending on which LLM you use. Some models are a lot more comfortable with buffering than others. If you are curious, the code is in the Agentic Java repo. You can try it out. Yeah, the point of this demo isn't really the game. It's showing the agent scope can handle messy, unpredictable multi-agent situations, not just clean step-by-step workflows. Werewolf is about as far from a fixed workflow as you can get. So that's the agent scope Java. The basic idea is straightforward. We take care of the hard stuff at the framework level: security, reliability, performance, context management, and so on. You can spend your time on what your agent actually is supposed to do so. If anything here catch your interest, check out our repo and give it a try. Thank you for hearing my presentation.
Thank you very much for joining. That was really, really great. Yeah, context is everything when it comes to agents. I mean, it really is. Makes such a difference. So thank you for sharing that. That's great.
Mm-hmm.
Yeah. There doesn't seem to be any questions, so I think if it's okay with you, we're going to move on to the next session. So we're right on time. Thank you. All right, so yeah, thanks very much. Next up, we have Andres Almore. He's going to talk about deploying to production with confidence. I don't know. Generally, if you do everything, if you do all your testing in production, to me, that's confidence. But I think Andres might have a different approach, something about risk. So let's bring on Andres, and we'll talk about it. Oh, before we do that, I just want to mention the survey. So we do have a survey. Please do fill out our survey. We want to make sure that we have the best experience for our attendees for now and the future. So please do share your thoughts and reviews of our sessions and our event. Much appreciated. And do go to JDConf as well. If you haven't signed up yet, you do get Microsoft rewards points for signing up and for certain tasks that you'll find out about when you go to jdconf.com. So let's bring on Andres, and we'll talk to him a little bit. Hey, how are you? It's been a while. How are you?
Hey, Brian, how's it going?
Doing good. Doing good. It's great to see you again. As always, fellow Java champion, and looks like a great topic. As I mentioned before, testing in production, that's one way to go. That's what I do with my demos. That's why they let me write demos. And but yeah, very, very vital topic. CI/CD is very important. CI/CD security and item potency, as they say, reproducibility. So
Yeah.
I'll let you take it away. Thanks.
Right. Thanks so much, Brian. Oh, let me show the slides immediately. So thank you everyone for joining today. We have a few minutes to talk about this topic, which is one of my latest passions. And there are so many things that we can cover, but with the time that we have allotted, we'll see how it goes. So this is me. This is one of the things that I like to do is talk to people around the world about open source technologies and open source methodologies, and that's exactly what I'm here. I'm going to give you a little bit of a story, a little bit of context, and then we jump immediately into the different topics that we're going to cover. So some of the things that I'm going to mention today may sound familiar to you. So back in the day, this is me. I like to just walk, write code and work on some puzzles every single week. I enjoy really working with code. But as time progresses through the week, you're getting close to the weekend, and then your thoughts start to move into what are you going to do later? Are you just going to meet with friends and have a good time? And in my case, because I live in Switzerland, well, I would like to most likely go out into the wilderness and go hiking into a mountain or a lake. So many things to see in the country. So that's exactly my point. On a late Friday or an early morning Friday, then you're just thinking about what is going to happen during the weekend and not so much what's going to happen with your production code. But then obviously, this is when things usually go wrong. Someone decides to deploy it on production on a Friday, or something was not working properly, and then just get alerts, and well, there go your plans for the weekend. Now, do you remember what happened? I think it's close to 10 years ago in the JavaScript ecosystem, when a package was unpublished, and then the news reported that the internet was broken by 3 days because there were so many different applications and projects that depend on the package that was no longer available. So we in the Java space saw that and said, hey, well, that's not going to happen to us, right? Well, December of 2021, we got Log4Shell, and this was the awakening. Because all hell broke loose. We didn't know exactly what was happening. Suddenly we got calls from the manager, from the customer, asking, hey, are we impacted? We don't know. How can we solve this? Customers are just really, really angry that their orders are not going through because the systems are down, this and whatnot. It was really, really bad. And that was us, developers, trying to figure out how to solve this problem directly in production in order to minimize the downtimes of the systems. Well, we eventually find out a way to solve this. Actually, there were a couple of ways to solve this particular issue. But the important bit is that we still have questions. How did this thing happen? How can we prevent this from happening again? And when it happens, because it's a matter of if rather than when, what can we do in order to minimize issues and to make things work better? So what we can do is to look back into what happened then and look at all the reports of the different companies and organizations that put our information out in the wild and say, hey, this is what happened, this is how we solve it, and you could learn from these things. In order to make this work, we need methodologies, we need tools, we need access to a few things that did not exist before in order to make this work a bit better. Now, we are going to cover a few of these tools. And they are more, of course, and depending on the ecosystem that you are dealing with, on the different versions that you're dealing with, you may have to look for alternatives. Now, the first thing is we should be doing testing. If you are still not doing testing, and this is something that Brian mentioned, testing on production, please don't do that. We kind of joke about it. Sometimes we do it, but really, we do have to have some sort of automated testing way before we hit into production. This is a quote that I like to mention when we talk about testing. This Alberto Savoia said this back in Java 1 2006. It's almost 20 years ago, because Java 1 back in the day used to happen in May. If you are just getting into unit testing, you're already too late. So if we are not unit testing our code today, just imagine how behind we are. So it doesn't matter what kind of testing you do, if it's unit integration, is functional, on some sort, or even manual testing, it will work in this case. We have to have some of that. If we're not doing testing, then we already lost. The next step is thinking about your releases. And in this case, what I would recommend you is to find a way to automate your releases. There are many tools out there that make it happen. Some would like to start using bash scripts or another scripting language, which is okay to begin with, but as time progresses and your application continues to grow and your projects grow, then just relying on a handful of bash scripts is not really a good idea. What I would recommend is to find a schedule, or you define the schedule where you can publish artifactory releases. So the typical example here would be, as you may be aware, the JDK, or the OpenJDK releases come out every 6 months. So that's the release schedule. We know as consumers that we can have a new version either in March or in September of the current year. So we can prepare accordingly and make sure that we can jump into the next release whenever that happens. So it's the same idea. You can decide to release every week, every 2 months, or once a year, and make that information available to your consumers. And if the time comes when you need to change it, because there could be many reasons to make this happen, then also document that and put out information out there so that your consumers be aware that this is going to happen, when this is coming, so that they can jump into the next release whenever it's ready. Once you have decided when you're going to release, the question next is, where are you going to put out the binaries or the code? Well, not actually the code, but the artifacts that the consumers will be able to grab and use. As a developer, it's very easy for me to tell other developers, look into a Git repository and then follow the build instructions, set up all the dependencies and requirements, and you may get something out of that, and probably you can use it. But that's not very useful for the end consumer. It will be much easier for a consumer to just use the current means that they have, whether it's a package manager. So in the case of Windows, it will likely be Winget or Scoop. If you're using Mac, it will be probably Homebrew or Mac ports. If it's Linux, there is a wider range of different package managers you can choose from. So my recommendation here is that if you can provide your binaries to a package manager, then do so. The next question you may have in mind will be, how do I make that happen? What do I need to learn? What different files are out there that I need to take care in order to make sure that the package manager can find all the information? So things start to pop up. And sometimes you also need to provide digital signatures or other additional metadata files during your release process so that package managers can perform their job well. This is where I bring a tool called Go Releaser. This is a tool that I discovered 6 years ago that it works for the Go ecosystem and a few other languages, but sadly not Java. So what Go Releaser does is that it creates GitHub releases with release notes, and it can create all the different files for package managers. It can create a Git tag. It can do a lot of things, but sadly it doesn't work for Java. Well, there is a project out there called JReleaser. Now, as the name implies, it has a J on it, so it probably has to have some Java on it. And because of the logo, well, it's also Duke and it's Java. And this is the alternate version to Go Releaser. This is the one that works for Java. And it can work for other languages as well, but we're talking about Java today. So this does exactly everything that it says that in the slide. It can take care of signing your artifacts, publishing to different places, whether you want to upload to cloud buckets, whether it's Azure or Amazon S3 compatible or something else. So many different things that you can do. Now, what it does is that you keep using your build tool of choice, that what you use today, whether it's Ant or Maven or Gradle, or in the case of Rust, it will be Cargo or something else. And you provide an additional metadata file, the your releaser configuration file. And then you can do a lot of things. So you can release to different locations, you can package to different package managers, and you can also announce different distribution channels. So maybe you want to send a Mastodon message, or you want to send an email or a Slack notification or something else, but your releaser has you covered in this regard. There are a lot of things that the tool can do. If you just want to release, then that's the blue column. That's a little different steps that you can invoke over with just one single command, or specifically which one of those. Or if you want to package, that will be the column in the middle. Or if you want to announce, that will be the green column. So this is just to tell you there's the possibility of things that you can do with this particular tool. Now, releasing is not enough, because at some point, someone can clone your project and create binaries of their own and maybe inject malware. So we have to find a way to identify who is the person or who is the responsible of providing such binaries. You probably have heard of PGP, pretty good privacy. And one of the things that I don't like about PGP, actually, this is not necessarily because of PGP, it's just the fact that I need to rotate my credentials every so often. Because if they have been compromised, then, well, there it goes, my identity. For this reason, a project was born, I think it's close to 6 years ago, which is called Sigstore, that allows you to handle digital signatures in a different way, in such a way that you can rotate the keys much easier, and you can handle key management much better. As a matter of fact, they do have a way that is called keyless, where you just sign an artifact and then just throw away the keys because the keys are not important. How? Because Sigstore works in this way. You can sign artifacts, and then the action of signing is recorded on it's an append-only ledger. And this ledger is visible. So even if the keys are lost, as long as you have a reference to that ledger and to the artifacts that have been signed, you can verify that the action happened and who did this. And because the ledger is public, you have the rest of the community behind it, so that this is really, really a hard chance for someone to mess something up. So you can sign, you can verify, you can look into the ledger, which is called record, and this makes things much, much easier. So there are other tools out there that are taking advantage of Sigstore. There is an open ticket out there to support Sigstore for consuming dependencies for Maven Central, because right now we depend on PGP. But hopefully in the future, we also be able to use Sigstore signatures for deploying to Maven Central. The next item is, okay, assume that, well, we have tested, we have released, we know who is doing the release because we can sign. But the binary is coming from the right location. Can we identify that the binaries were created from a specific set of servers or some other place, right? So this is where SALSA comes in. And SALSA means supply chain levels for software artifacts. And what this particular framework, and when I say framework, it's not about code, but it's more like guidelines or things that you can do and apply to your development practices, is we can define metadata about the location and the processes that we use in order to build the artifacts. Now, as you may be aware, the software supply chain, it's something that we use every day. But there are many places where an attacker can come in. The first one would be us using, so us developers could try to use social engineering. And this is how the XZ exploit started 2 years ago. And they can attack our source code, they can attack our dependencies, our build tool chains, the service, so many different places. So what SALSA strives to do is to reduce the surface of attack for all these different locations where we are building and where we're using the SDLC. Now, this SALSA does it by defining a series of levels on how we are building stuff. And most of us are probably right now in build level 0, which is anything can go. In build level number 1 is when we have a documented release process. Most of it should be automated if you can. So it's somehow this release process is automated. The next level, level 2, is where we are protecting the build from being tampered. This is when we already, with this metadata, this provenance is signed, and surprise, the default way to sign these things is through SIGSTO. And we can also record all information where the binaries were built and which tools we use to build, information about the environment, all these things. Well, we're not done yet, because an attacker may still come into our build toolchain or the build servers. So the next level and the final level is when we harden the build platform. So we have taken measures and steps in order to ensure that whenever you are building on a new node, for example, you're building on GitHub where you're cloning a specific image that has a set of artifacts and software required in order to build what you want to do. Now, this is safe to begin with, and you can apply it or you can add new packages. So as long as you use specific hashes or versions of tags and everything is pinned, the versions are pinned, so you know exactly who and what is being used, then you're good to go. And there are a few other things. So if you were to look into the documentation of SALSA, it will tell you exactly what you can do. Now, SALSA is being sponsored by an open source foundation. It's called the Open Source Security Foundation, where you can also find SIGSTO and a few other projects. So if you have not heard before of the OpenSSF, well, now you know there is this organization that can take care of tools and methodologies and information so that you can have a much better experience securing your software. Now, even though that we have covered all these things, there are still more things that we could do in order to make this work. And the latest one is coming thanks to Log4Shell. Once this happened, there was an executive order that came out in the US in order to ensure or to force providers that were working with the government to deliver what is known as an SBOM, a software bill of materials. And if you have to deal with customers in Europe, then now you have to also tackle SBOMs, because there is a law called the Cyber Resilience Act, or CRA, that also enforces software providers to deliver SBOMs whenever they are needed. I'm not so sure in Asia Pacific if there is some sort of legislation or laws in different countries that will also not just encourage but enforce the use and the creation of SBOMs. So keep track of that in wherever you are located, because depending on where you are or who your customers are, you may need to do this. Now, there are a couple of formats that you can have access to. One is SPDX, and the other is CycloneDX. They record most of the same information. One of them is a bit more verbose than the other. It could be in XML format. Another can be in JSON format. So there is a tool out there called SIFT that can generate SBOMs in both formats, SPDX and CycloneDX, and do the translation between one another, and also can use XML or JSON, whatnot. These are not the only tools. There are a few others out there, but it's important to recognize that whenever someone asks you for an SBOM, or if you need to consume an SBOM, then you can use these things. The information that is recorded in an SBOM is typically when the SBOM was generated, what is the metadata on a unique identifier for your particular project, what is the list of dependencies, and this is the important bit, that were used or you require in order to use this particular software or library or an application, what have you. There are hashes for each one of these dependencies, the version numbers, and the licenses. And because we have this information, what dependencies are required for your application, you can go into other processes such as vulnerability scanning. So now that you have this list, you can tell if a particular dependency has any recorded CVEs or is vulnerable or it can easily be attacked. This is the main use of SBOMs today, but because of the metadata that these files contain, you could do more things later. The next thing, and I think it's almost the last bit, is make our builds repetitive, but also our artifacts reproducible. Perhaps you have heard about reproducible builds. This came from the Linux ecosystems. The idea is that you can rebuild a whole distribution for source. And if I do the rebuild, I can compare that with another build that someone else did. And if they happen to be equal bit by bit, and this is important bit, every single bit of information has to be identical. If something is odd, if an executable bit is not present or a character is out of place in an XML or a JSON file, then the whole thing is not reproducible. There is a tool out there called DefScope that allows you to perform a def into binary. So it's kind of like you're doing a get def, but it tells you exactly if there were to be any difference within the archives of binaries, where this information will be. So that now you can track that and fix it. Now I'm going to do a quick demo of some of these features that I talked about, and I'm going to switch to the terminal, and I'm going to showcase. Actually, let me show the browser. I have a project called Hello World Java Salsa. This is a very typical Hello World application written in Java. We're using Maven for the build. And what this project is going to do, we're going to create this archive, and then we're going to publish to GitHub. You notice that right now we don't have any releases. And if I were to show you the GitHub actions that I'm going to make use of this thing, I have a GitHub action that's going to trigger anytime that I make a push to the main branch. And this is the GitHub action that I'm going to make use whenever I want to make a final release. And with this particular bit, there are a few things that are a bit outdated. Probably they have to be updated. I'm going to set up a particular version of Java. And then I'm going to kick up a particular release workflow here. This particular release workflow knows how to use JReleaser, the tool I mentioned earlier, in order to build a project, create the binaries, and then invoke the Salsa attestation. So this information is found here in the release configuration. This is very similar to what we saw before in terms of Maven. So there is some metadata about your project. This is information that you could typically find in the POM XML. Information, where are you going to post the release? So I'm going to post to this GitHub repository. I want to assemble an archive. So this will be the zip file, which will be reproducible. I can show that when I run it on the command line. And also I'm going to generate SBOMs for that particular artifact. So I'm going to run this first by kicking the release workflow. And I'm going to also show it in the command line. So these two processes that I'm going to run will be independent. So this is going to take about a minute. So once this thing is running and it kicks up, and you can see there are different stages that will happen. So I can jump now back into the terminal. I have the project here. I'm going to build it with Maven. So this will create the jar file. The next thing is I'm going to tell JReleaser that I need to find a particular version of my project. In this case will be project version, I think we have version 1.0.0 snapshot because that's what we built. So we said that. And now I can say, JReleaser, which version do we have? It's version 1.23.0, latest. Now I can ask JReleaser, tell me what you know about my project. And this tells me, well, you have a distribution, you have catalogs if you want to generate SBOMs, and you have some assembly to create a jar, zip files, and a few other things. Good. So we go back and we have built already our library, which is Hello World 1.0.0 snapshot. The next bit we're going to tell is JReleaser assemble that particular zip file. So we call assemble. And now we got a Hello World snapshot. Now, two things. First, notice the date for my particular, the last commit is this one, April 18. And when I look into the artifact, in this case will be out, JReleaser assemble Hello World archive. The date here is the same as the commit. So we're making a reproducible timestamp. And all the entries are sorted also reproducibly. So This makes sure that we can have a reproducible artifact. Let's come back to the our browser. We see that we're still doing the build. We're done. So now the SASA provenance is going to be generated, this metadata file. And once that metadata file is done, then we can push it to the release. Let's look if the release has been already done. Here we have, now we have a release with some default release nodes. And here we have the different artifacts. We have the SBOM that was generated by the tool. We have the zip file. We have some checksums. We did not configure signatures in this case. And once the release is done, let's see, we're still doing, we will see that there will be an additional file. Here is a SASA upload, the last step. And once this thing is done, we can go back to the release. And there's a SASA attestation. So this is the file that you can use, the metadata, in order to verify that everything that was published in this release, it was created by myself. It was published on GitHub with these particular environment settings, all these things that I mentioned before. Okay, so we're pretty much done. I know that I mentioned a lot of things, and including these tools and these methodologies encourage you in changing your release process if you have it. So it's very likely that it's going to take you some time to learn these things, and your teammates and even your manager will question why we need to do these things. We just need to go to production as quick as possible. It does make sense, because it's not a matter if Log4Shell or something similar is going to happen. It's definitely going to happen. It's a matter of when, and we have to be ready. Okay, so everything that we saw today is open source. If you have not contributed to open source before, it's very simple. You encounter any issues with what you saw today or any other open source library or project or dependency that you have, file a ticket. You don't have to send code, but just tell the people at the other side of the wire, hey, I'm using your project, I encountered an issue, can you have a look at it, provide enough information, and continue that discussion and that conversation so that the project can become better. All right. So with this, I thank you very much. I hope that you enjoyed. I know there was a lot to cover. And if there are any questions, then I'll be very happy to take them.
Thank you, Andres. As always, great session. We don't have any questions in the comments. If anyone does have a question, please do ask there, and we can pass it on to Andres as well. I guess, I mean, you covered a lot of this already. I do have my own questions, which is, you know, how do you basically use AI when you're improving older applications without creating new technical debt? Do you have any insights into that?
I don't know exactly, because I don't use AI that much. Most of the people that I hear talking about the topic, when they're saying that the AI agents are now up to a point where you can claim they do the same work as a junior. If that is the case, and then we'll have to treat these agents in the same way I was do the juniors. You still have to look behind the shoulders a little bit and do a little bit of hand-holding. And does that actually increases your speed? Well, it depends. If you have a host of new juniors joining your team, how much time do you have to spend in order to look over, and what's the process that you use in order to graduate these juniors into the next level?
Yeah, great. Good answer. So thanks. I think we'll wrap it up there and bring on Christian. Thank you very much for joining us. You did share a link for source code demos, things like that?
Diffoscope? Yes, I can also share the slides, and I can share all the content that we saw today.
Awesome. Great. Thank you. Thank you.
Thank you, everyone.
All right. Thank you. All right. So next up, we have Christian Schuster from CERN. He's going to be talking about maintaining legacy applications with AI tools. A very important topic when you're talking about the kind of tools that they have at CERN. Let's bring Christian on. Thanks for joining, Christian. Yeah, this is great. I really appreciate you joining for this, and looking forward to some insights here. I assume, for example, maintaining legacy applications at CERN is a pretty key thing. I mean, I'm thinking when you're talking about the Large Hadron Collider, for example, you might have, if you don't maintain it properly, you might have some build errors followed by the universe folding in on itself and imploding. Is that about right?
Yeah, I think it's a bit less dramatic than that. But the thing is, you also have situations in which we need to handle huge enterprise systems similarly to any kind of enterprise, right? And
Data.
since we're a public institution, it's not like we can afford rewriting everything every single day, right? So legacy is just a fact of life here. So it's you need to kind of have a look at what's possible, and if AI tooling can help you, then by all means you should jump on board.
Absolutely. I can imagine that maintaining the huge amounts of data that you have produced with your instrumentation, for example, would be a huge challenge, and making sure that you don't affect that data when you're updating systems. Yeah, that's a big one.
Yeah.
All right. Well, I'll let you get started, and thanks for joining.
Right. Thank you very much. Okay, so let's get started. My name is Christian. I'm going to be talking to you about maintaining legacy applications using AI tools. So as a subheader here, I put safe refactoring, test first, MCP, and agentic tooling. We're going to go quickly through each of them because we only have around 25 minutes. So let's get started. So who am I? I work at CERN. For people that don't know what CERN is, it's the European Laboratory for Particle Physics. So basically, it's the place where the Large Hadron Collider lives. It might look like I work in construction, but that's just because safety first at CERN. So I've been here for around 8 years so far. I come from a computer security background, but I also worked in data engineering for quite a lot of time. And for the past 4 years or so, I've been working more in enterprise systems. So everything which keeps the engines running, like ERPs, any kind of enterprise, huge enterprise Java systems that we maintain at CERN. So we're going to be talking about not how AI replaces developers, right? So if you came into this talk just expecting that there's going to be a magic bullet which basically replaces you and you just give it the work, technically nowadays you can do it with a lot of the tooling that's out there. But the point here is more about reducing your cognitive load when you're interacting with your big legacy systems, and also to have the tools to confidently tackle unknown situations, unknown problems, right? Like you might face in a huge code base. So there's actually a very interesting paper here. Well, you can take a screenshot or whatever. It's on arXiv. It's about AI usage patterns. So people have been testing how people use AI and when are they the most successful in actually completing a certain task, right? So if you rely fully on delegating stuff to AI, it takes long-ish, right? This is for quiz scoring, right? So maybe it's not 100% applicable to programming, but it's still something. And if you look at generation then comprehension or hybrid code explanation, this is like quite powerful in the sense that you use the AI as a tool to kind of understand the code faster and easier, also avoiding passing too much context so that your AI tooling is overwhelmed with whatever you're doing, right? So basically the whole point here is you're slicing up your application up to a certain point where it's manageable and understandable, and you don't get wrong answers back from whatever you're doing. So the findings suggest that AI enhanced productivity is not a shortcut to competence. So AI systems should be carefully adopted into workflows to preserve skill formation, right? So especially if you want to learn, like if you have junior engineers in your company, rather than telling them to delegate code to the machine, it's rather you should work together with it to solve your problems. All right, so let's learn how AI helps you understand legacy code. Then maybe talk about adding tests before starting any kind of refactoring in your code. How to fix, let's say, real bugs in between codes using MCP and ACP, protocols that you might have heard of before to constrain and guide AI. And as a bonus, we're also doing this without any kind of paid models. So we'll see this in a second. Right, so let's look at the tooling and how to orient yourself in legacy code. So what's the legacy in legacy, right? Because we're talking about legacy code here. But this is not about age. It's more about lack of safety, right? So usually you don't have any tests. You don't have you have implicit contracts. So things that people know to be true, but it's not documented anywhere. You have hidden coupling, business rules, which are embedded in the code. So it's quite hard to figure this out, especially for a new developer coming to your team. And we have quite a large amount of turnover in my organization, for example, which means we're going to need to actually have to tackle all these problems, right? But first, let's look at the tooling, right? So it's dangerous to go. Take this. Talking about tooling, one very interesting development that came out of the community recently is the agent context protocol, agent client protocol. So basically, this is a way of plugging in any kind of AI models into your editors, right? So this comes from Zed, one recently developed IDE. But JetBrains is also implementing this, and there's a lot of others which come with it. So that's pretty cool. We're going to be using OpenCode for the demos here. So OpenCode is well, as the name says, it's an open source coding assistant, coding agent tool, if you want, which can connect to multiple backends that we're going to see in a second. So it's really powerful. We'll keep it for the demos, right? So yeah, in terms of stack, we're running Light LLM. So Light LLM is an open source project with 3 models that are hosted at CERN, actually. So I can just connect to it from my local machine here and talk to the AI models which are hosted on our infrastructure. You can also use local Olama and whatever. It's the same principle, and you can have the same results, basically. And then we use ACP, like the agent client protocol, to talk to these models and perform agentic workloads with lots of privacy concerns being thrown out the window, because you're just talking to your own infrastructure. You're not sending anything to a cloud provider, which you might be worried about, right? Right. So legacy orientation, reading before writing. So the whole idea is we need to understand what happens in the code first, right? Especially thrown into a big project, and the description of the current business logic. Let's check some examples for that. So we have a legacy project here. It's well, a fake legacy project in between codes, which contains a bunch of things you might expect in a Spring Boot application, right? So we have a order processor class, which contains a bunch of business logic, right? So there's a meaty function here called process order, and inside process order we have, you see, like processing order, and then there's like find order by number, la la la, and then there's like a bunch of logic here which is hard to parse already, right? So there's this thing here, there's something which is already marked as a bug. Okay, fine, thank you for the help there. And then there's a lot of other different branches here, which may be really hard to understand, right? So you might have seen this in code that you yourself have been using in production, right? Now, in order to well, understand what happens there, this code, basically these exercises, actually they come from a larger workshop, so we can just use a couple of pre-baked prompts here. One very useful tool that I find to understand the project just by looking at it like this, of course, you can just run through the whole project by yourself through the structure, or what you can do, you can just use your AI tooling in order to generate a nice little diagram that we're going to see here. So let's fire up OpenCode and see how it looks like. Right. And here in OpenCode, I can actually switch between different models that I have set up through my Light LLM instance. For the configuration and so on, actually, just as a side note, it's quite easy. It's a JSON file where basically you pass the different providers that you have, your API key, base URL, and so on, and then maybe MCP servers and all that. And if you have them hosted on your machine, then basically you can just switch to, for example, DevStral, right? So this is a Mistral-based coding agent, and we have 2 ways of talking to our AI models. So we have either agents that are doing things, so build agents, and plan, right? So if I press tab here, you can see that I'm switching between them. So actually, let's look at the plan mode over here. So it doesn't actually change anything in my code, and we can copy that prompt that I have here. So the prompt says, let's read the following files and produce. Okay, pasted 9 lines. Okay, let's see. Yeah. So basically, we're trying to generate a concise map of everything that happens in our project, right? So basically, what happens behind the hood is the fact that your open code provides some tooling inside itself to interact with your file system, right? So then it can actually go and talk to different files and so on. It can. So now it's basically telling me what are the risky code paths here, what advice it has for me, so like implement proper error handling and so on. So this is maybe things which you might have already seen if you looked at the code, but this is kind of a zero effort way of doing it, right? So one other interesting thing that you can do is like generate a small mermaid diagram for, and then you can reference a file, right? So for example, order processor, right? And then basically this will create me, well, in this situation, it's creating a flowchart. This is the flowchart of the business logic in this situation, which is pretty cool because if I go here to mermaid.live and paste in my flowchart, let me just kill this. Voila. You see, so basically this is a very digestible way of well, a diagram of flowchart, right, of how the application behaves, right? So this is the order processor. You check for duplicate orders, you validate, you update order ID, validate different things, calculate tax, set tax rate, apply VAT discount, and so on and so forth. So this is way more manageable than just jumping into a huge code base of unknown code. So it's one of the really best tools that you can actually have out there that can help you well, tackle your legacy code, right? So let's move on. On top of that, we can also do a few interesting things here, which involve more writing code rather than reading code. So this, if you haven't heard of characterization tests, there's a very good book by Michael C. Fellers. It's called Working Effectively with Legacy Code. It's well, it's not extremely new, but it's still quite valuable nowadays as well. So you can write characterization tests to basically explore your current code and explain how the application works before touching anything. So we want to refactor the application to make it more readable, right? But first, we should write some tests which actually describe the current behavior, even if it's wrong. It doesn't matter. The point here is that you want to generate the tests that will tell you if you refactor too much, right? You refactored up to the point where actually things start breaking. You don't want that. You want to keep the same, let's say, behavior of your system as you keep on changing things in the engine while the car is running, right? So you kind of have this big ball of mud application, right? And then you're going to need to understand what's going on. You do it piece by piece through these characterization tests. Okay, let's have a look at some examples there. So as I was saying, we can actually integrate with the model context protocol through with the ACP stuff, right? So basically what I do here, I can talk to DevStral directly from my IntelliJ editor over here, and I get basically the same results, right? Just maybe with a bit less explanation. So the thinking part is not shown. And if I go here to basically say, okay, I want to build, write me some characterization tests for, let's go order processor. Yeah, make sure you cover all the edge cases. Yeah, we can refine that prompt, of course, but basically what's happening here is that, of course, it looks at the code structure, does it uses a glob call basically to see everything inside our file structure. It reads different related files, so order.java, legacy application test, and so on. And yeah, while it does this, basically, you can, of course, you can refine your queries way more. So you can say something like, okay, given order processor, process order propose, 8 edge cases worth testing. For each case, point to the exact branch line that right? So you can go quite far. You can also use plan mode, right? So by default, instead of actually changing anything, you can just tell it, please propose to me the changes, because then you have the history of your chat, and that history will actually be very useful for your agent to produce better results in the implementation. All right, well, while this is running, we can actually go back to our presentation here, right? So once you have your, let's say, your characterization test developed and you understand what the code does, right? You might have identified some bugs along the way, right? So because the behavior is documented with the tests, you can start breaking things, right? So you can add some tests which basically fail, or you can change something in the code and see the test failed. And then you basically adapt reality so that it reflects what you expect your business logic to be, right? So you go from the unknown of not knowing what the business logic does up to the point of reflecting, well, your expectations through, well, carefully tested code, which will, well, the test won't pass if you do something wrong. So you have a safety net there. Okay, open code completed the task. Amazing. So now, thank you for the synchronization open code. That's perfect. So what it created here, it's basically just a standard Java test file, right? With a bunch of mocks here. So we're using Mockito and the library and so on. So, and then it tests the existing business logic, right? So here, basically, if I want to run the tests, we should be able to see well, them passing or failing. Maybe some of them fail for some reason, but some of them actually pass, right? So if we go to order processor test here, and there was something with 99, no tax 99. This one actually passes, right? So set discount code, no tax 99. So if I put non-tax 98 instead here, or actually even better in the order processor, I change something here in the business logic, run the test, or even run that test in particular there to make it easier to see. Well, this one passes for some reason, because we probably said something weird here. Because it doesn't return anything when you find order by number. Of course, this might vary depending on your tooling that you use. What we can do, we can, well, just get rid of all of this. Yeah. So I have actually like a branch set up, characterization tests. Voila. So in here, actually, we have a bunch of tests here. Characterization, order processor characterization test. Yeah, and there's one which fails because this actually catches a bug. So test division by zero and tax calculation. So should be NaN, right? So not the number, but the answer is something else, and you can basically use this to fix your application, right? So expected true but was false, so it was something else that returned there. So basically, we should check where the division by zero happens. Of course, now that you have a failing test, you can just ask your agent to actually do it for yourself. All right, so moving onwards, we can talk a bit about refactoring as well. So for example, if you want to look at the payroll module, so we have two different modules in this application, ordering and payroll. We haven't touched it so far, right? So you would go by a similar approach. You would start with the module. You would extract a high-level diagram of understanding what the thing does. You write characterization tests for the behavior. You refactor it, focus on what you want to target, and then you rerun the tests. And of course, there's one interesting thing that you can do here. It's called the strangler fig pattern, if you haven't heard about it. So to simplify our life and make it actually fit into the demonstration. So I'm going to check out the refactor branch, which is basically something that I have refactored myself using AI tooling. And what we started to do basically is look at the payroll module and transform it into something implementing hexagonal architecture, right? So basically we have a domain, we have an application, we have an adapter, which is the controller itself. And what you do is basically you start implementing the new functionality, like the completely refactored functionality, while leaving the existing code running there. When that happens, basically you can build your new iteration. When you're confident enough that your new implementation is as good as the old one, you switch, right? In this situation, given the fact that it's a REST control, it's very easy to switch. You can just point to the new API endpoint that you created, and that's it. So I'll let you actually explore the code by yourself and see what it does. But basically, it's a really powerful tool if you use it properly for refactoring, right? All right. Cool. And let's talk a bit about context, right? So the big problem with all these AI models is the fact that we can't fit everything into them, right? So if you have a huge spaghetti code kind of application and you want to, well, refactor everything, you won't be able to fit all the information inside, right? So you have two ways of doing this. You can define an agents.md file, which basically allow you to tell the model what to do, or you pass exactly what you need to refactor or to change, or all the, let's say, the context information that it needs, so it can do a good job on fixing your application. Otherwise, hallucinations increase and you get worse results. And another good way of doing this is using model context protocol. This is basically a way of allowing you to interact with your different agents. So let me just quickly configure this here. Settings, all right, AI assistant, model context protocol. So here we don't have any kind of server configured. What I can do, I can add an HTTP server, because I know that I have an MCP server running locally, developed in Spring AI. So localhost 8081 SSE, this is the protocol that it uses. I can add it to, well, project, yeah. So, and maybe give it a name. I shouldn't have called it some, well, this is the working directory, sorry. Yes, and hey, HTTP, right. Let's see, docs. All right, cool. So this is offline right now. We're gonna get back to it in a second. So let's check out our branch with the MCP server and just run our MCP server. This, okay, Gradle, let's go. Yeah. Okay, we're gonna get to the code in a second. So basically what we do here is we go back to our settings. AI assistant, model context protocol. And then, wait a second. Yeah. Well, I can show it to you from open code actually to avoid the debugging now. So you can see here that it says MCP status one MCP server basically, right? So what I can do, I can actually like I can toggle MCPs, and you can see that there's legacy docs which is connected. So basically what I have here is an MCP server which provides me documentation. You can imagine this plugged into your Confluence instance, for example, where you have documentation. So tell me something about my legacy docs. And we expect it to actually, yeah, exactly. So it calls, you see it actually prints out the tools that it's using. So in this situation, it just gets the legacy docs list, and there are 3 of them, right? So we have payroll, business logic, payment processing, and orders business logic. So each of them are basically defined and explained here, and you can use this information to actually generate well, meaningful documentation, meaningful code in your application, and so on. And the sky is the limit, because this is just basically a Spring Boot application with a couple of annotations. So in this situation, it basically just returns some text, right? I have something, an annotation called @mcp tool, right, which basically says, okay, this is legacy docs list. This is what my agent can call, and there are hundreds, thousands of MCP servers implemented in everything you can imagine, including IntelliJ, right? So for example, if you're using IntelliJ, you can actually plug in an MCP server to talk to IntelliJ, so it can look at the file structure, at code, and so on and so forth. All right. Right. Let's go. So yeah, and you have multiple ways of implementing MCP. So you can use different transports, standard input and output, or remote calls using HTTP, SSE implementations, and so on. So yeah, just to wrap up really quickly, you have a lot of options, basically, especially for hosting things locally. So play around, try different options, see what it works. Of course, maybe paid models would actually give you better results. So think about that. Use agents.md, use MCP for example, documentation, like internal organization-specific documentation, small diffs, characterization tests, and so on, and use tools that are for your specific use cases, right? You can access the code if you want to leisurely browse everything at your own pace. And then basically, if you want to contact me in any kind of way, you can use these social media platforms or my email address. Thank you very much.
Thanks so much. That was awesome. Great, interesting, real-world applications, real-world tool set, interesting tool set as well. So thanks for sharing all of that. That was great. Yeah, I think we're going to wrap up there. So thanks for joining. That actually concludes the Asia Pacific segment of JDConf. We basically had. We started strong with Josh Long, who did what he does, brought us an awesome Spring AI live coded demo where a dog gets adopted at the end. I love the doguments. That was pretty cool. Then we had Niels Yoma, who talked to us about the requirements behind agentic coding, showing how better specs and BDD personas can help improve context. Hi, Michael then basically extended the context discussion with how modern Java pattern matching can make agent orchestration easier. Orchestration is one of the most important things right now. So having a pattern matching way to do that is a pretty cool technique. Jenny Ferry shared real world examples of Microsoft's Agentic DevOps implementations with some awesome skills that will be added to Awesome Copilot, which is some skills there as well. We also had my colleague Yoshio Terada talking about modernizing large monolithic systems, and Hiking Zhang introduced Agent Scope Java, which is basically a great enterprise-ready agent system manager that has security and can build prototypes quickly. Andres gave us some techniques about conversion of production readiness. No testing in production is allowed, but how AI tools, how production readiness with software supply chain security can be implemented easily and quickly. Christian Schuster with CERN. I hope you didn't mind my joke, talking about a pretty awesome set of AI tools that they use with MCP to maintain and evolve legacy applications at CERN. Yeah, basically we had a great mix of AI integration, modernization, orchestration, security, and enterprise readiness. Next up is EMEA. So EMEA, we've got a great lineup as well, including myself in a few hours. So it starts basically 3 hours from now. I know we have multiple time zones around here. It starts 3 hours from now, and we're basically going to start with Christian Solov. He's going to talk about self-improving agentic systems with Spring AI. Simon Ritter is going to give a great interactive look at modern language features for Java. Ron Veen is going to talk about AI-assisted modernization, including the Dutch version of the IRS. And Alex Soto will talk about Playwright for Java, which is definitely kind of a sleeper tool. If you haven't used it yet, please do check that out. It's pretty awesome. His session should convince you of that. Oleg Solajev is going to talk about Docker sandboxes and what it means to run AI agents more safely with some of the cool AI capabilities they have now in Docker. I'll let him, won't give any spoiler alerts. I'll let him cover that. Laura Trotta is going to talk about Spring AI and Elasticsearch to make RAG more approachable. Anything to make RAG easier is always great. And I'm going to be closing the session with AI accelerated CI/CD patterns. I'm going to show you how you can actually call GitHub Copilot from your GitHub Actions, among other things. So pretty cool. Now, all of these sessions are going to be on demand. We also have a really strong on-demand lineup who's already out there. It is here. I've once again got one of those sessions myself about agent orchestration. We also have sessions on building production-ready multi-agent control planes, Java ecosystem security through DevSecOps, LLM integration with Java, Oracle to Postgres migration with VS Code and Copilot, trade-offs with AI code generation, agents in the IDE through ACP, context engineering with LangChain for J, and building APIs into secure, observable, and designed to evolve cleanly. So check back in 3 hours. We're going to be firing up everything again at 2 a.m. Pacific time. It's 3 hours from now, whatever your time is. And I'm going to be there hopefully full capacity in a few hours to deliver that as well. Please do check out the survey. We'll put the survey link in the comments. And the QR code here for that as well. We want to make this event the best experience it could be, so your feedback is valuable to us. What else? Is there anything else I can think of? No, I guess that's about it. Thanks for joining. Please do check out the on-demand sessions if you're watching a recording of this. Otherwise, we'll see you in 3 hours for the EMEA sessions. Thanks very much.